Hi students, welcome all to Om Institute, and this video we are going to discuss the solutions of the All India GATE 2026 online mock test that has been conducted Saturday 10th of January, and hope you have performed in the examination really well. And don't worry, even if you have not performed that well, don't worry, GATE exam is still one more month away or slight more than 1 month. Okay, whatever learnings you have got from the mock test, try to implement, try to improve on that areas, because 1 month is again a sufficient time. If you know your shortcomings, if you know where you could not score, you can definitely improve onto that. All right guys, so let us get started. The first subject that I am taking here is mathematics. Okay, so the rank of this particular matrix. Okay, the rank of this particular matrix. See, if you just apply one operation, okay, to convert into row echelon form, you know that this matrix is not in the row echelon form. Okay, but what is the operation if I start doing here? This is -6, multiply the above number by 2, and then you add, you'll get 0. Similarly, multiply above number by 7, so you'll get 21, and then you can subtract here. But you know that the operations are applied on the entire row or entire column. Elementary row operations I will apply here rather than a column. So what I'm going to do is, as I just mentioned, R2, I'm going to do R2 plus twice of R1. Okay, twice of this, and then R3 I'm going to replace as R3 minus, okay, 7 times R1. Okay, on doing this, the structure of the matrix that is going to be left in front of you, 3022. Now see, -6 plus 2 into 3, 0. 42 plus 0, 42 only. 24 plus 2 into 2, this is 28. 54 plus 2 into 2, this becomes 58. What is going to be next? 21 minus 7 into 3, this got 0. Minus 21 minus 0 will be minus 21 only. 0 minus 7, 2, minus 14. And minus 15 minus 14, minus 29. Now there are total 3 rows. This is a 3 cross 4 matrix, and what you are able to clearly see, you can even apply the next step to convert exactly into the row echelon form. Okay, I'll tell you two things here. You can stop here and you can say that these two rows are clearly dependent on each other. Why? Because you just multiply by 2. 21 into 2, 14 into 2, 29 into 2, or rather minus 2, you will get the second row. So what can I say here? In this matrix structure, the second row is nothing but minus of minus 2 times R3, right? That means there is a dependent row. Okay, so how many independent rows? Out of the 3, 1 row is dependent. There are 2 linearly independent rows, and the rank is equal to number of independent rows or number of independent columns, whichever way you see. So rank of the matrix has to be 2. Rank of the matrix has to be 2. Or if you want to completely go into the REF, okay, so one more operation, because these two rows are equal. So what I will now do is R3, I am going to replace as R3 now by R2 by 2. Add this. Okay, you divide it by 2. Okay, this becomes 21. You add, you get 0. This becomes 14. You add here, you 0. This becomes 29. You add with this. So R3 is entire R3 row is going to become 0. Okay, 3, 0, 2, 2. Next we have 0 and 42 and 28 and 58. Okay, and 0. Then as I told you, all these numbers are 0. Now this matrix is clearly in the row echelon form. Why? Because what is the condition for row echelon form? Okay, the number of starting zeros, the number of zeros at the beginning of any row, I call it as starting zero, must be in increasing order. And if there is a row of 0, it must be at the last. Okay, both the things are satisfied. So this is clearly row echelon form. And whenever a matrix is in row echelon form, rank is equal to number of non-zero rows. Okay, so you are able to clearly see one row has become 0. So how many non-zero rows? 2. The rank of the matrix is 2. The rank of the matrix is 2. Okay, next question. Okay, a basic question on complex number understanding, MCQ 1 mark it is. If W is a function of Z given as Z minus 1 upon Z plus 1 and modulus W less than 1 gets mapped in the Z plane. Okay, so if you plot or if you map mod W less than 1, so first of all, what is modulus of W? Okay, what is going to be modulus of W? I'll extend here only. If I, to make it simple, see, any mapping for you will be, any graphical mapping for you will be simple if you convert into XY format. Okay, because what type of curve or what type of surface or what is coming is easily understood if you have the XY relation. You have the habit of seeing into that. Okay, so you can write down this as x plus IY minus 1 divided by x plus IY plus 1. Okay, or separating the real or imaginary part, x minus 1 plus IY divided by x plus 1 plus Iy. This is what is going to be. So when I have to calculate modulus of W will become how much? You check here. Okay, under root of x minus 1 square plus y square divided by the under root of x plus 1 square plus y square, real part square plus imaginary part square, correct na? Okay, so when you simplify this, what are you going to get? Okay, you are going to simply get this whole under root. Let me write. Numerator will be x square plus y square plus 1 minus 2x. Denominator will be x square plus y square plus 1 and plus 2x plus 2ab term. Okay, and if you want mod w less than 1, if you want mod w less than 1 here means this numerator will be less than the denominator. So I can simply write down x square plus y square plus 1 minus 2x must be less than the x square plus y square plus 1 plus 2x. Okay, this is how I can write down. Okay, now clearly x square y square 1, x square y square 1 cancelled. Okay, so what is only left is minus 2x is less than the 2x, or effectively you can say 4x greater than 0 adding here, or x greater than 0. Now x greater than 0 means what? Okay, right half plane. X greater than 0. X is what? In the z plane. This is x, the real axis. Okay, this is y, the imaginary axis in the z plane. Okay, so x is greater than 0 means entire right half plane. Option number B for this one. Okay, option number B for this one. Easy one. Okay. Anyways, next question. Number 3. So there is a differential equation given, MCQ 1 mark. Okay, with initial value y0 equal to 1. What is the value of y1? Okay, sorry, this is not MCQ. It is NAT. Okay, this is NAT. Okay, so let's have a look into it, dear. Okay, what is there? 1 plus dy by dx plus dy by dx whole square, etc., etc., etc. Okay, now see, to simplify this differential equation, identify the left side. This looks like what? 1 plus x square plus x cube. Okay, the left side. And the 1 plus x square plus x cube is nothing but the expansion of 1 minus x whole inverse. 1 minus x whole inverse. That means the given differential equation can be written as 1 minus x, that is 1 minus dy by dx whole inverse is e power x. Okay, so for that reason, it's a basic, decent question, I would say. Easy, but you have to apply that logic. How do you simplify the left hand side? Or you can then write down 1 minus dy by dx equal to e raised to the power minus of x. Equal to e raised to the power minus x. Now, what is dy by dx? That will become 1 minus e power minus x. 1 minus e power minus x. That is what is dy by dx, correct? Okay, so let's integrate both the sides, or separate the variables first. Dy equal to 1 minus c power minus x dx, and when you integrate, what is going to be y? Okay, so integral of x will be, integral of 1 will be x, integral of e power minus x will be plus e power minus x. E power minus x upon minus 1, so minus minus plus plus the constant of integral, for which the initial value has been given to you. Okay, what is given to you? Y0 equal to 1. Okay, at x equal to 0, y should be 1. Okay, so I'll put y equal to 1 and x equal to 0. If x is 0, e power 0 will be 1 and plus c. So 1 and 1 cancel, c value will be actually 0. So answer, if they ask the solution, okay, so y equal to x plus e power minus x. Okay, to convert to NAT question, I put it as y1. So what is the value of y1? Value at x equal to 1. 1 plus e power minus 1, which will be approximately 1.367, something of this kind. Okay, e inverse. Okay, approx 0.37 you can write. 1.37. Okay, so this is what is going to be the answer. Okay, this is what is going to be the answer. Next question, dear. Okay, NAT 2 mark question. A conceptual one, okay, not a very lengthy one, a basic one, but a conceptual one from the linear algebra. Let M be a 3 cross 3 matrix such that M into some vector is equal to x is equal to 6 minus 3 0. Now, important point here is, are these two vectors related? Yes, if you call this as x na, see, minus 2 into 3 or into minus 3, 1 into minus 3, 0 into minus 3 will be 0. So this can be written as minus 3x. And for any matrix such that mx is minus 3x Okay, this is again like the relation Ax equal to lambda x. Okay, eigenvalue eigenvector relation such that x is known as the eigenvector. Okay, for which the output is a multiple of x, that is the eigenvector, and then this number is known as the eigenvalue. We all know that. Okay, so then what is the condition here is x is the eigenvector. In the given story, x is the eigenvector. So minus 3 becomes what? Minus 3 becomes eigenvalue. Okay. Now, suppose that there is another matrix M cube, okay, the cube of the same matrix, into some vector 1, minus 2, 0. Important point is, now this vector, if you take this vector and just divide by minus 2, minus 2 by minus 2, 1, 1 upon minus 2, minus half, 0 upon minus 2 will be 0. That means this vector is just a multiple of this vector, and for any matrix, important point, for any matrix M, okay, if the eigenvector is x, okay, any multiple of it will always be eigenvector because eigenvectors are not unique. Okay, so if x is eigenvector, k into x will always be eigenvector. Okay, for the same eigenvalue, why? Because mx equal to lambda x, na? So automatically m into kx is also lambda into kx. Okay, so suppose you call it as some vector y, so you can say like this, my equal to lambda y, correct na? Okay, so still y is the eigenvector with the same eigenvalue lambda. Okay, so if x is the eigenvector for a particular eigenvalue, k into x is again an eigenvector for the same eigenvalue. Okay, so anyways we know for one particular eigenvalue, eigenvectors are not unique. Now important point is, if m has the eigenvalue lambda and eigenvector x, m power n, okay, has the eigenvalue lambda power n, eigenvector x. One of the very important and property repeatedly onto which you will find PYQs in GATE as well. Okay, so m power n will have the eigenvalue lambda power n into x. Okay, or if this has the eigenvector kx, here also it will be kx. Okay, so important point is, as I told you, this, if this is x, this is x by 2 or divided by minus 2, minus x by 2. So this is also an eigenvector. This is also an eigenvector. If m has the eigenvalue minus 3 and eigenvector x, or eigenvector x, or minus 3 or eigenvector minus x by 2 also, okay, then m cube will have what condition? M cube will have what eigenvalue? Minus 3 in cube and same eigenvector minus x by 2. That means m cube into the given minus x by 2 vector. What is the minus x by 2 vector? 1 and minus half and 0 should be equal to how much? Okay, minus 27 times the applied vector. Okay, that means this is minus 27, then 27 by 2 plus 27 by 2 and 0, and they have just simply given it as alpha, beta, gamma. Okay, what is the question? Okay, what is the modulus alpha, beta, gamma? Alpha plus beta plus gamma. Alpha plus beta plus gamma whole modulus. Okay, it is the modulus of minus 27 by 2. Minus 27 plus 27 by 2, and that becomes 13.5. Magnitude wise 13.5. Okay, a concept question I told you from linear algebra. Good one. Okay, 13.5 is the answer for this particular question. Okay. Next question from mathematics. Suppose that the random variable u has the uniform distribution on 0, 1 and x equal to minus 2 log u. What is the PDF of x? What is going to be the PDF of x? Okay, have a look into it. Derived distribution, okay, for which you can use the CDF concept as well. What is given? The random variable u has the uniform distribution on 0, 1. That means what about the PDF of u? What about the PDF of u? Okay, the PDF of u, let me write it this way, FUU will be simply 1 upon uniform distribution means constant PDF, 1 upon length. What is the length of the interval given? 1. Okay, the 1 upon 1 minus 0, 0 less than equal to u less than equal to 1. Okay, that means simply it is equal to 1 for 0 less than equal to u less than equal to 1. Okay, if I alone want to sketch the PDF of u, okay, it should look like this. From 0 to 1, it is constant. Okay, now what is given is, okay, x is another random variable minus 2 log u. Correct? Na? And I want the PDF of x. I will start with the CDF of x. CDF of x. Okay, suppose f of x. The CDF is given by the probability x less than equal to x. And that will be equal to the probability minus 2 log u less than equal to x. Okay. Okay, so I've converted to the u because u PDF is given, so I can calculate any probability around u. This finally becomes the probability that log u minus 2 you send on the other side, so it becomes greater than relation minus of x by 2, or you can call it as probability u greater than equal to e power minus x by 2, sending the log on the right side, it becomes exponent. What is the probability u is greater than e power minus x by 2? Okay, suppose this is some value e power minus x by 2. What is the probability u is greater than this? That means area under this PDF for this much part. Greater than e power minus x by 2, and of course maximum is 1. Okay, how much is this area? Okay, so this will be equal to the area for u is greater than equal to e power minus x by 2, and area, rectangle area, height into base. Height is 1, base will be the difference of these 2 points. Height is 1 and the difference is 1 minus e power minus x by 2. Okay, so I have the final CDF of x. Okay, the CDF function is simply 1 minus e raised to the power minus x by 2. Of course, the range of x also you can, determine. Okay, so because if u is equal to 1, log 1 will be 0. Okay, and if, see, the simple logic is u is between 0 to 1. Okay, so log of u. Okay, when any number less than 1, the log is negative. Okay, log is negative. Okay, but minus 2 log u will be greater than equal to 0. Log will be negative, minus of log will be positive. That means x will be positive only. X will be positive only. Okay, for x greater than equal to 0. Now the question is PDF, relation between PDF and CDF. PDF of x, the PDF is nothing but the derivative of the CDF. And if I differentiate this, I will get simply 1 by 2 e raised to the power minus x by 2, which is the exponential PDF case. Lambda e power minus lambda x. The very commonly known as the exponential PDF, lambda e power minus lambda x. So correct answer here is option number B. Option number B. 2 marks MCQ it is, okay? Next question. Let fx be a function which gives the smallest integer greater than equal to x. Okay, smallest integer greater than equal to x, also known as ceiling function. Why? Because if I give you any simple integer, suppose as 1.23, okay, what is the smallest integer greater than or equal to x? So see, what are the integers greater than this? The greater than this integer are 2, 3, 4, 5, but this goes up to infinity. Which of them is the smallest? 2. Okay, that means the integer above it. What is above you? Ceiling. There are two functions, the ceiling and floor. This one is the ceiling function. Okay, so the value of the ceiling of this, okay, so if you want to write down f of 1.23, it should be 2 above it. Okay, now come here. There are two parameters given, MSQ question to talk about a and b value. A is limit of x tending to 0 minus log of f sin x upon 1 plus f cos x. Divided by, let's find both of them. Yeah, here again I have written is log of f sin x. See dear, for your convenience, because the limit is around 0 minus and 0 plus, okay, have a look into this waveform, which is the sin x waveform. Okay, how will the sin x waveform be? Correct. So that you can easily understand, let me also draw the cos x waveform. For cos x, 0 minus and 0 plus will be same because it is the even symmetric function. You anyways know it. Right? This is 0. Okay, this is 0. Now come up here to the question. Okay, what does the question say? Log of f sin x. What is f? Okay, the ceiling function. But 0 minus, when x is tending to 0 minus, what about sin x? Okay, x is tending to 0 minus means once x is closer to 0, x is approaching 0, but from less than 0 value, somewhere from here. And if x is less than 0, sin x will also be less than 0. Okay, sin x will also be less than 0. Okay, sin x will be less than 0. Tending to 0 but less than 0. Now, because it is less than 0, okay, suppose here What is the integer? Ceiling. Integer above. What is going to be the integer above? 0 only, na? What is the integer above? 0. Okay, so this becomes the case of log of 0. F sin x will be 0. Okay, f cos x not required, but let me still tell you. Okay, now 0 minus, yeah, before just 0, what will be the cos x value? Okay, between 0 and 1. Okay, now if the cos x value is between 0 and 1, the upper value, ceiling means upper integer, will be 1, na? Will be 1, na? Okay, so this becomes 1. F of cos x will be 1. Okay, but what is log 0? Minus infinity. Similarly here, okay, x tending to 0 plus. So 0 plus will be here, na? Even very close to 0, not this much far, but okay, just imagine number above 0. Okay, sin x also becomes above 0. Sin x also positive. Okay, now if sin x is positive, even minutely positive, but what is the integer above it? Will become 1. The integer above it, this will be the ceiling value. This is 1. Okay, so f of sin x is going to become 1. F of cos x again will be 1. Okay, because this side or this side, both side cos is same. Okay, but what is log 0? Log 1 is 0. Okay, 0 by 2 is 0. So minus infinity and 0. A will be minus infinity, B will be 0. C answer and B answer. 2 answer correct for this MSQ question. Okay, a decent question on understanding of 0 minus and 0 plus limit mixed with the ceiling of cosine and sine function. Okay, next question. Number 7. Suppose that we have a coin which comes up head with the probability P, tails with the probability Q. Okay, now suppose that this coin is tossed twice. Okay, let E be the event that head turns up on the first toss and F be the event that tails turns up on the second toss. Which of the following is or are true? Okay, probability MSQ question. Okay, so you have a coin which is not a fair coin, but it has a probability of head equal to P, probability tails equal to Q. Now it is tossed twice. It is tossed twice. Let E be the event that head turns up on the first toss. Now, whenever any coin is tossed twice, what is the sample space generally? I'll write here. Okay, the possible outcomes may be head on both. Okay, HT or TH, head on first, tail on second, or vice versa, tail on first, head on second, or both tails, TT. Okay, there are 4 outcomes on and all, sample space. Now, let E be the event, I'll write here. Let E be the event that head turns up on the first toss. Head turns up on the first toss. What is there on the second? Unknown. What is there on the second? Unknown. So there are 2 cases, na? There are 2 cases. It may be HH or HT. Second could be anything. But if I ask you what is the probability of this event? Okay, what is the probability of E event? That means probability of getting a head on the first toss. Okay, probability of head on the first toss. It is simply probability of head on the first toss is P. Is P. No need to consider these 2 probabilities separately and add. Still it will be same because second is don't care. Okay, so when second can be anything, the sum of all probability for second event will be 1. That is not required. Okay, now F be the event that says that tails occur on the second toss. Okay, on the first I don't know, but on the second it is tail. So it becomes HT or TT. HT or TT. Okay, but again if I ask you alone, what is the probability of F? What is the probability of F? Probability of getting a tail on any toss, first, second doesn't matter. Probability of getting tail on any toss is given as Q. Okay, is given as Q. Okay, so these are the individual probability. Now, what is the set E intersection F? Do they have anything in common? Okay, see, HT and HT. This is common to both. Okay, it is HT. So, E intersection F is not a null set. Is not a null set, because if the intersection is a null set, then they are said to be mutually exclusive. Otherwise, they are said to be mutually inclusive. They are mutually inclusive. They include something in mutual. Yes, they are mutually inclusive. Okay, if they don't have anything in common, they are said to be mutually exclusive, you know. Okay, then what about E union F? What about the E union with F? So when you take the E union with F, what is going to happen? When you take the E union with F, okay, so when you combine both, you are going to get HH, HT, HT is common to both, and TT, HH, HT, TT. Does it equal to omega? Does it equal to sample space? No. If the intersection of 2 sets give you the sample space, then it is known as mutually exhaustive. Okay, so it is not giving the entire outcome. So these 2 events are not mutually exhaustive. Okay, these were the first 2 things that were discussed. Not mutually exhaustive, correct? Not mutually exhaustive. So they are inclusive? Yes. They are exhaustive? No. Okay, now are they independent? Okay. Are they independent? Let us have a look into this here. What is the probability of E intersection F? E intersection F is HT, na? It means probability of HT, head on first and tail on second. Head on first P, tail on the second Q. P into Q. Now, P of E intersection F, is it P into Q? Now, what is P? It is PE. And what is Q? Q can be written as PF. So, P of A intersection B is PA, PB. The events are independent. Now, you forget this calculation. Okay, if you have attended, the classes earlier by me, I have always told you that coin tosses are anyways independent. E is the event which is talking about the first toss. F is the event which is talking about second toss. And whatever happens on the first toss, head or tail, doesn't matter, cannot determine what will happen on the second, or cannot even alter by 1% also. It cannot alter what is going to happen in the second toss. Right? Coin tosses are always independent. So yes, automatically also you can say E and F, because they are the events of first and second tosses. Two different tosses of coin, they have to be independent. Correct? And anyways, I proved to you, P of A intersection B is PA, PB. That is the rule of independent events. Okay, now P of A complement intersection F complement. See, you can solve it by Venn diagram, but let's solve it by a simple logic. Na? What is there? Okay, what is E complement? What is E event? What is E event? Okay, E event says that head on the first. So complement says that head should not come, so tail should come. E event does not talk about second toss. Okay, the second toss can be anything. E complement means first should not be head. Okay, similarly, what is F complement? F event is tail should be there on the second. Okay, now tail should not be there, and if tail is not there, head is there on the second. Okay. So then if I ask you, okay, what is going to be the combination of this P of E complement intersection F complement? Okay, it says that there should be tail on the first and there should be head on the second. So it is like TH. And what is the probability of TH? Tail on first P, head on second P. Q into P is same as P into Q, and P into Q is P of E intersection F. So yes, P of E complement intersection F complement is same as P of E intersection F. Option number D also correct. Okay, 3 answers correct, ACD, except B. B was not correct. Other than that, 3 options are correct. Okay, fine. All right. The 8th one and the last one from mathematics, MSQ question, basic vector calculus. For the vector function xi plus y, xi I cap plus yz j cap plus zxk cap, choose the correct option. Line integral along the straight line joining 0, 0, 0 and 1, 1, 1. So see, A option is a simple one because they are asking about line integral along a straight line joining 0, 0, 0, 1, 1, 1. What is the equation of straight line joining origin and 1, 1, 1 directly? Okay, I mean, if you wanted this equation, you can write here x minus a upon x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1. Okay, so what do you simply get is x equal to y equal to z. Okay, this is the equation of line. Now, option number A, calculation I will solve here. The line integral f dot dr or integral f dot dl, okay, can be written as fx dx, that is xy with dx, plus what is the y component? yz with dy plus zx with dz. But this is to be done along a line, and what is the equation of the line? All x, y, z are equal. So automatically their differentials are also equal. So I can substitute them, and the integral is going to become, this becomes x square with dx. Next becomes again y into z is x into x. So everything is x square, then dy is also dx. Third term also is x square, dz is dx. Okay, so total x, 3x square. Integral 3x square dx, and integral 3x square will be x cube. Limit of x 0 to 1. Answer will be 1 minus 0, which is 1. Correct. Limit of x 0 to 1. Na? Okay, x alone 0 to 1. Correct. Okay, so A option is correct. Surface integral over the surface of the cube. Now, surface integral over a cube where cube makes a closed region. Okay, because cube makes a closed region, you can apply the Gauss divergence theorem to solve the second part. And for Gauss divergence theorem, you will require divergence. So answer number C. And MSQ options are somehow connected sometimes. Okay, so option number C will also come into action. So what is the divergence of the vector f? What is going to be the divergence of the vector f? Okay, let me just solve it here first. Okay, yz, sorry, the first component is xy, then I cap, then what is next is yz, j cap, zx, k cap. Okay, what is the divergence of f? What is the divergence? Okay, del by del x of x component with x, del by del x of xy, del by del y of yz, del by del z of zx. When I solve it, here x derivative 1, y is constant, so z constant, y derivative 1 plus x constant, z derivative 1. It is y plus z plus x. Okay, the divergence at origin, option number C, the divergence at origin. If I put 0, 0, 0, the divergence will be 0. Correct. Let me also check the curl here. Then I'll go to option number B. What about the curl? Okay, the curl of the vector, you know, is solved by this determinant ijk, then writing down the partial derivative terms, del by del x, del by del y, and del by del z. And then the vector components, which are xy, y into z, z into x. Okay, this is what is going to be the curl of f. Okay, so when you solve it, what are you going to get is I cap del by del y zx is 0, partial derivative del by del z of yz will be y, so minus of y, minus j cap del by del x here z minus del by del z of xy 0. Okay, plus k cap del by del x here 0, del by del y here is x. Okay, so minus x. Okay, so net answer is minus y I cap minus z j cap minus x k cap, and when you put down the value at origin, okay, this value will be 0 only. Okay, so at the origin the curl of f is non-zero, wrong. Okay, so yeah, we have got C answer correct as of now, A answer correct, B we have to check, D is not correct. Okay, we have checked B also, sorry, not this is not B, this is about C, and this is about the D part. And now coming to the B part. Okay, what is there in the B part? Surface integral over the surface of the cube. Okay, integral f dot ds. Okay, over the surface of the cube, because it's a closed region. So by the Gauss divergence theorem, you can write down this as integral divergence f dv. Okay, dv is dx, dy, dz, because it is in Cartesian coordinates. What is the divergence calculation? Is x plus y plus z. Okay, so this is going to be triple integral x plus y plus z dx, dy, dz. Okay, the limits of all x, y, z are 0 to 1, 0 to 1, 0 to 1, 0 to 1, y also 0 to 1, z is also 0 to 1. Since all the limits are constant, you can integrate with any variable of your choice first, or since all the variables are constant, you can solve by separating the variables as well. Okay, like first is x with dx, x square by 2. Okay, first term alone, if I solve x with dx, then dy dz, dy integral y, dz integral z, plus split it up. Now when you solve the second one, y with dy, y square by 2, dx integral x, dy, y with dy, y square by 2, dz integral z. Third case, okay, third case, dx dy and z dz. So dx integral x, dy integral y, z dz integral z square by 2. Whenever all the limits are constant, you can solve by separating out the variables in single step. Then put down the limit 0, 0, 0 to 1, 1, 1. Whenever you put the lower limit, all the terms are 0. And when you put the upper limit, okay, all x, y, z are 1. So 1 by 2 into 1 into 1. So this is 1 by 2. Next term again 1 by 2. Next term again 1 by 2. Net answer is 3 by 2. And it is not equal to 1. The options B said that 1. So no. Okay, the B wrong. A and C are the two answers correct for this MSQ question. Right. Now, moving ahead to, these were the 8 questions, 13 marks from mathematics we have kept as a standard pattern. Okay, there were, you know, hope you have understood and hope you have performed here decently. Okay, let me tell you, there were 3 questions of 1 mark and there were 5 questions of 2 mark. This is how total 13 marks, okay, have been there. You can also individually mention, how many marks you scored from maths. Please do mention in the comment box. Like that you can mention for every subject, okay. Next, let us start with the signal and system questions and the discussion. Okay, first question, MSQ 1 mark. which of the signal given below is or are periodic? Okay, which of the signals is or are periodic? Okay, summation delta n minus 4k minus delta n minus 1 minus 4k. Okay, or let me start with the direct ones. Okay, see, e power j, what is this? J, e raised to power j, 10n. Okay, discrete time, if it was continuous time, e power j omega t is always periodic. Okay, but in discrete time, you first check the 2 pi by omega. That is 2 pi by 10 and pi is left, it is irrational. And in discrete time, if 2 pi by omega is an irrational number, the signal cannot be periodic. Okay, so this is definitely aperiodic. Now, what about un plus u minus n? How do you plot un? If it was continuous time, things are again different. Ut plus u minus t is 1, but in discrete time, what is un plus u minus n? In the discrete time, see, this is how un will start. Unit step signal. It is constant 1 starting from origin. But I have next considered u minus n. U minus n is the mirror image of it. So mirror image, whatever is at origin will remain at origin. So when you have origin already 1, you are going to add 1 plus 1. So origin value, only origin value will be 2. Okay, but the mirror image of this, okay, this value will be 1. This value will be 1. Okay, this also will be 1. So all these samples there are 1. Okay, but the value at origin will be 2. Hence it is aperiodic. Hence it is aperiodic. Okay, one sample breaks the periodicity. Okay, otherwise it is constant 1 except at origin. It is except at origin. We also write down this signal as not 1 but 1 plus del n. Okay, that is what. See, if it was continuous time, okay, my focus is just on this question, but just adding on to one point. Ut plus u minus t always 1. Okay, un plus u minus n is 1 plus delta n, another 1 value extra at origin. Okay. Now, okay, what is this in B option or in D option? Now see, D option I'll come first here. What is 2 pi by omega? Okay, what is 2 pi by 2 pi? Okay, for the first signal, what is 2 pi by omega? I'm telling you, dt time you have to be first checking whether 2 pi by omega is a rational number. Not only rational, it is integer. Automatically it is rational. Now when 2 pi by omega is integer, the time period is also the integer value 1. Okay, what about the next one? 2 pi by omega, 2 pi by 6 pi is 1 by 3. It is not integer. So time period cannot be non-integer. Discrete time, only integer time is allowed. But is it at least rational? Yes. It is 1 by 3. It is rational. So the signal can be periodic. Okay, if the signal is periodic with period 1 by 3, 1 by 3 cannot be officially taken as period. But if any signal value repeats after n, it will repeat after 2n, after 3n, after 4n, after 5n. So what is the final period we take in such case? We take the period as any multiple of 1 by 3, so that final answer is integer. So that final answer is integer. So if you take k3, you will get the n2 value as 1. You will get the integral time period. So like that I will say the value repeats after 1 by 3, 2 by 3, 3 by 3, which is 1. Okay. And 1 is an integer, so time period can be 1 here. What is the final time period then? The final time period is LCM of n1, n2. Okay, but both are 1, so LCM will be 1 only. So this is periodic, okay, with period 1, although they didn't ask the period. Okay, so C is periodic, A and C are not periodic, D is periodic, B. Okay, what is there in B? Easy one only. Okay, what is there in the B? Xn is given by summation delta n minus 4k minus of delta n. Okay, a slight shifting minus 1 minus 4k. Okay, for k being from minus infinite to the plus infinite, correct? Okay, so now suppose you had taken k0. Okay, there will be several terms. If I take k0, I'll get delta n minus 1. Okay, then if I take k1, so similar impulse will repeat, delta n minus 4 minus delta n minus 5. Okay, if I take k1. Next, if I take k2, delta n minus 8 minus of delta n minus 9. Okay, that means if you wanted to draw, okay, this with reference to n, you are first going to get an impulse at origin. Okay, delta n and then minus of delta n minus 1, impulse here. Okay, negative value. Then directly you get an impulse at 4 and 5. This value 1. This value will be minus 1. Then directly you get the impulse at 8. So very clearly you are able to see that repetition has occurred. Na? Okay, it is periodic with how much fundamental period? 4. Similarly, if you take k negative like -1, delta n plus 4 and delta n minus 3, n plus 3. Okay, so it will be repeated from minus infinite to infinite only. So B answer will be periodic. Yes, the B will be periodic in nature. Okay, done. B and D. Next question from signals. The frequency response of a discrete time LTI system is given to you, h omega minus j from 0 to pi plus j from minus pi to 0. The correct statement about the impulse response of the system. The correct statement for the impulse response of the system is how much? Now have a look into it. Okay, what is h omega? Okay, if you identify, again a MSQ question, if you identify h omega minus j for right side plus j for left side, that means same value, same magnitude, but opposite in sign. That means it is odd. It is an odd function. Not only odd, it is pure imaginary. Only the value are j and minus j. Okay, now Fourier transform is pure imaginary and odd if the signal is real and odd. Okay, if the signal is real and odd. Okay, so the signal Hn, impulse response Hn will also be real and odd. If a signal is real and odd, then only the Fourier transform is pure imaginary and odd. Correct, na? Okay, so Hn is real, correct. Hn is odd, correct. If it is real, the conjugate symmetric is automatically ruled out. Conjugate symmetric is a symmetry property for complex function. Okay, right? Now, what about D? Summation minus infinite to infinite modulus Hn whole square. Do you need to find Hn for this? No. Okay, this is based on Parseval's relation. So, one more point mixed up here. Parseval's relation, the energy of the signal. Okay, summation modulus Hn square is also equal to 1 upon 2 pi integral for one time period. That is integral minus pi to pi modulus of h omega whole square d omega. But whether from minus pi to pi, what is the modulus of j or minus j? Both of them have the magnitude 1. That means modulus h omega, if you draw the magnitude spectrum, will be simply 1 here. Okay, so 1 upon 2 pi only. What is modulus h omega square? 1. Okay, so 1 d omega, d omega integral omega. Okay, d omega integral omega, upper minus lower limit total 2 pi and 1 upon 2 pi times 2 pi, answer is 1. So D answer is also correct. Yes, D answer slightly took you towards Parseval's relation. Parseval's relation. Parseval's relation. A, B, D. A, B, D. Third one. If the ROC of a signal is 1 by 3 less than mod z less than 2, what about the ROC of x minus n? What about the ROC? Now see, if signal xn has the z transform xz, the signal x minus n has the z transform x1 by z. That means the poles will be reciprocal and the right sided part will become left sided. Now you see, okay, 1 by 3 to 2. That means if you talk about xn, I'll split this way. Okay, mod z is greater than 1 by 3 and mod z is less than 2 with respect to 1 by 3 greater than with reference to 2 less than. Okay, for x minus n, what will be the condition? Number 1, dear, the pole at 1 by 3 will become 3. The pole will be reciprocal. Okay. The poles will be reciprocal because the entire function becomes a function of 1 by z. The poles are going to be reciprocal. Okay, poles are going to be reciprocal, right? Okay, so for 1 by 3 the pole will become 3 and the right sided part will become the left sided. Okay, because x minus n, if xn is right, x minus n mirror image will go to left and left sided means mod z less than. Now second part, mod z less represents some left sided part will become right sided. So mod z greater than, pole 2 will become 1 by 2. This is the condition. Okay, that mod z will be less than 3 but greater than 1 by 2 and that means between 1 by 2 up to 3, option number A. Logical question if you just apply the logic of ROC. Okay, next question. A periodic signal is given to you. Okay, NAT 2 mark. Xt equal to 2 plus summation k equal to 1 to infinity 8 upon k pi sin k pi by 2 cos 1600 k pi t. It is passed through the following system. What is the average power of the output? Now see, it is passed through an ideal band pass filter. Okay, whose cutoff frequency, whose pass band frequency is given 200 to 300 hertz and the unit gain is there. Okay, but how many frequencies are available in the signal? Okay, a periodic signal in its Fourier series representation is given. Okay, see here very clearly, if you just take out, this is the notation of the form C naught, the DC term, okay, plus summation k equal to 1 to infinity a of k, okay, a of k, okay, these are some coefficients ak cos k omega naught t. Okay, where omega naught, the fundamental frequency of the signal, will be 1600 or 1600 pi. Okay, this will be the C naught, the DC term. Okay, and this is what is known as the Fourier series coefficient. This will be the Fourier series coefficient of the signal. Now, what are the Fourier series coefficients of the signal? Okay, it only has cosine terms. Okay, the signal would be even in that case. Okay, that is why it only has cosine terms. Now, what is the AK? 8 upon k pi. Okay, sine of, okay, k pi by 2. 8 upon k pi sine k pi by 2, clearly suggesting that all this ak will be 0 if k is even. Why? Because if you put k2, okay, you will get sine pi 0. K4 to sine 2 pi 0. K6 to sine 3 pi. Okay, so sine pi, 2 pi, 3 pi, all of them will be 0. So you'll only get the answer at odd harmonic. So that means some hidden wave, some half wave symmetry will also be there. Hidden half wave symmetry, because DC term is there. Okay, forget the symmetry now. Okay, what I'm only telling you is the even components, the even harmonics will be absent. Okay, even harmonics will be absent. Now what about A1? What about A1? Acha, one more thing. How many terms are to be taken? If omega naught is 1600 pi, F naught, which is omega by 2 pi, is 800 hertz. The fundamental frequency is 800 hertz. Okay, so fundamental term, is it in the pass band? Yes. Okay, so 2 F naught 1600, 3 F naught 2400, 4 F naught will not be passed. Okay, so this frequency range, 200 less than equal to F less than equal to 3000. Okay, this will pass, this will contain F naught, 2 F naught, 3 F naught terms. Okay, F naught, 2 F naught, 3 F naught. Okay, because why? Because F naught is 800 hertz. Okay, so inside this range, F naught, 2 F naught, 3 F naught, but 2 F naught, okay, will correspond to the Fourier series coefficient A2, which will be 0. Okay, so only which harmonics will be passed? The first and third harmonic. The DC will also not be passed. Okay, so what is going to be the output? Unit gain is there. Okay, what is going to be the output? Okay, for that I need A1 and A3. Now let me write down A1. A1 is 8 upon pi, sine pi by 2 is 1. What about A3? A2 anyways I told 0. I'll write here separately. What about A3? 8 upon 3 pi. Correct na? 8 upon 3 pi, sine 3 pi by 2. Sine 3 pi by 2 is minus 1. So minus 8 upon 3 pi. Okay. So input is given as, rewriting the input, okay, 2 plus summation k equal to 1 to infinity ak cos k omega naught t. Okay, this is DC corresponding to omega 0. This also will not be passed. Output will be given by, output of the band pass filter will be given by, output yt will be given by only the first term F naught or omega naught and the third harmonic term. Okay, that is not even the DC. So A1 cos omega naught t plus A3, correct, plus A3 cos 3 omega naught t. That should be the output. That should be the output. That's it. Okay, so what is the power of the output? Now sinusoids of different frequencies are there, so power is additive. Okay, power is directly additive because you have sinusoids of different frequency. Okay, so what is the average power of the output? Amplitude square. If it is A cos omega t, amplitude square by 2. So A1 square by 2 plus A3 square by 2. Correct, na? That is what you will write. A1 square by 2 plus A3 square by 2. Okay, right. What is the A1? 8 by pi. Okay, so 1 by 2 I will separate outside. 8 by pi whole square plus the next one is A3 square, that is 8 upon 3 pi minus 8 by 3 pi whole square. Okay, 8 square 64 common, divide by 2. Okay, in fact 64 by pi square is common, so this is 2 pi square. Then what is left? 1 plus 1 by 3 square is 9 here. Okay, so 32 by pi square into 10 by 9. This you have to approximately solve and write down the answer. Okay, let me just write down how much approximately will be the answer. Just a second. .6 approximately. It is turning out to be 3.603 if I round off. So 3.6 you can enter. Correct, na? So good question. A good analysis question based on filter and Fourier series components. Okay. Next question from signals. Number 5. Consider a causal system with the transfer function s minus 2 upon s square plus 4s plus 4. Okay. 1 second. Denominator can be further simplified, na? S square plus 4s plus 2, it looks like s plus 2 whole square. A square plus b square plus 2ab. So s minus 2 upon s plus 2 whole square. This is what it is. Now what should be the ROC? Okay. So the pole here will be s equal to minus 2 minus 2. That is a repeated pole. Okay. So what about the ROC? Okay. Sigma greater than minus 2 or less than minus 2? Causal. Causal means right-sided ROC. If it was anti-causal, I would say less than. But here sigma greater than minus 2. This is the entire details of the given transfer function or Laplace transform. Now for an input xt equal to 1, okay, whenever a constant input is given, remember, okay, see how do you solve this question? Whenever xt is any constant a, okay, this can be written as a e raised to the power 0t, and remember e raised to the power st for any complex number as well. Okay, the eigensignal concept of continuous time system. For e power st, output is given by h of s e raised to the power st. Okay, that means for this the output yt will be given by a e power 0t. So what will come? H of 0 e power 0t. Okay, e power 0 again 1. So a h of 0. So if the input is a constant input a, output will be a into h0. Okay, so here what is the input given to you is 1. What is the output then? Okay, 1 into h0. That's it. Okay, what is the h0? H0, okay, minus 2, okay, by 2 square. If I put s0, simple. Okay, so that is minus 1 by 2. Okay, now see, what is the s value I'm using? Okay, 0. What is the s value I'm using? 0. Okay, that is origin. Does it fall inside the ROC? Yes, ROC is sigma greater than minus 2. Na? That also is a required condition here. Okay, ROC is sigma greater than minus 2. And this is the point I am using. What point I am using? Origin. Okay, this is inside the ROC. This point, the S is inside the ROC. Then only this H of 0 will be defined. Okay, so output is constant actually here. If input is constant, output is also constant. Minus 1 by 2 for all t. Okay, for all t. What is the magnitude of the output at t0? At any time it is constant and magnitude is 0.5. Magnitude they are asking. Okay, so 0.5. Magnitude you will write as 0.5. Okay. Right. All right. Sixth question. Consider the cascade of two systems where system 1 is a first order RC high pass filter. Okay, what is the transfer function you write down for the first order RC high pass filter? Okay, and impulse response both we will discuss. And system 2 is a second order RC low pass filter. Second order RC low pass filter. Okay, so the transfer function, if you take the if you apply the input here VIT, and if you take the output as the output across the capacitor, you will get the V0 by Vi, the transfer function for this as 1 upon 1 plus SRC. This is what is the first order RC low pass filter. Okay, and when you take the output as the output across resistor, okay, when you measure this output as suppose V0t and this is the applied input VIT, what is the transfer function you get? V0 by Vi is SRC divided by 1 plus SRC, and that is what is the first order RC high pass filter. Okay, the transfer function corresponding, acha, what is the value to, what is one more thing told in the question? Okay, both have the time constant. Time constant means R into C. The time constant is RC for the RC circuit here, and that is 1 second. Okay, so for both RC equal to 1. Okay, so if you put down the RC equal to 1 here, if you put down RC equal to 1, you get 1 upon S plus 1. And corresponding impulse response HT is given by e power 1 upon S plus 1 is the Laplace transform for e power minus t ut. Okay. For the second one, if you put down RC equal to 1, time constant is 1, you get S upon S plus 1, which is further split as 1 minus 1 upon S plus 1. Correct? Now you simplify. S plus 1 minus 1 will be S. Okay. And the impulse response for such a system is given as delta t, because 1 is the Laplace transform for impulse, minus again 1 upon S plus 1 e power minus t ut. What is told? Now consider a cascade of two systems. Okay, so it's a decent question. First, you require the basic impulse response or transfer function knowledge of the RC, first order RC circuits only, low pass and high pass cases. And then you need to connect in cascade and overall impulse response. Okay, the overall impulse response sketch, approximate sketch we have to highlight. Now see here, what is the condition here? Okay, you have RC high pass filter having the impulse response h1t equal to delta t minus e power minus t ut, the time constant being 1, okay, to be connected in cascade with the RC low pass filter, first order case only, having impulse response suppose h2t and that is e power minus t ut. Okay, this is the system. So overall cascade combination, for the overall cascade combination, what is the impulse response? Whenever two systems are cascaded, the impulse response are convoluted, h1t convolution h2t. Okay, that means delta t minus e power minus t ut whole convolution e power minus t ut. Opening the bracket. Okay, anything convolution with impulse, ft convolution delta t will be ft. Replica, it is replica. So delta t convolution e power minus t ut, answer is e power minus t ut, minus, now same exponential convolution, e power minus at ut convolution with e power minus at ut is t e power minus at ut. Okay, t e power minus at ut, minus t e power minus t ut will be the answer. Okay, so I can take the e power minus t common, I will be left with 1 minus t, then e power minus t and into ut. Correct, na? This is what it is. Okay, now you see here what option has to approximately match. You see here, see if you take t0, okay, answer will be 1. E power 0, 1, only 1 will be left. If you take, see, now if t is between 0 to 1, if t is between 0 to 1, at t equal to 1, again answer will be 0. Again answer will be 0. But when t is between 0 to 1, so if t is less than 1, this answer 1 minus less than 1 will be positive. Okay, you will get some positive answer. Okay, so see, what is the pattern here? Okay, the value has to start from, not from 0. This is wrong here. Okay, A and D are wrong. The value has to start from 1. Okay, and at t equal to 1, it will become 0. Now, out of B or C, what is the value at infinity? That also we can figure out. Na? Okay, when t tends to infinity, let me write this way, 1 minus t upon e power t. 1 minus t, e power minus t shifted in the denominator. When you apply the L'Hospital rule, because if you put infinity, this becomes infinity upon infinity case. Okay, this becomes infinity by infinity form. So I can apply the L'Hospital rule. And then when you differentiate the numerator, I get minus 1. Differentiation of e power t is e power t. Now when you put infinity, denominator is infinity. 1 upon infinity is 0. So at t tending to infinity, answer has to be 0. At t tending to infinity, answer has to be 0. Then what will match? Answer is C. Answer is C. Okay, answer is C for this question. Okay, DFT, which is very important topic for EC students. Let there be a sequence xn equal to 2 del n plus del n minus 1 plus del n minus 3. Okay, the 5-point DFT xk of xn is computed. Okay, but if you have to compute 5-point DFT, you have to write down xn as a 5-point signal. Okay, so how do I write down xn as a 5-point signal? How do I write down xn as a 5-point signal? It is going to be at origin, the value is 1. Okay, then delta n minus 1 impulse at 1. Then there is no impulse at 2, so 0. Then there is an impulse at 3. Okay, but these are only 4 points. So I will include one more 0 here, writing it as a 5-point. Writing it as a 5-point signal so that you compute the 5-point DFT. Correct? That is what is required. Okay, the 5-point DFT of xn is computed and resultant sequence is squared to obtain yk. That is yk equal to x square k. Okay. Okay, so first we have to obtain xk, then yk. Okay, but what is yk? It will be the square of xk. I think then no need to compute the DFT. The square of xk means xk into xk. Because finally what they're telling, the 5-point IDFT is then computed to provide xn, to provide yn, to produce yn. Can you directly not tell what is yn? It is multiplication in frequency domain. So what should be happening in the time domain? Convolution. What convolution? Circular convolution. For periodic sequences, we have circular or periodic convolution. So yn is xn circular convolution xn. xn circular convolution xn. Okay. Yn is xn circular convolution with xn. Okay, that is what it is. So, then what is the summation modulus yk square? Again, the question is, do I need yk to solve this summation? No, this is again related with Parseval's. This is again related with Parseval's. Okay, see, what is the Parseval's theorem? Okay, what is the Parseval's theorem? Energy of the signal, summation y square n, yn being a real signal, summation y square n equal to 0 to n minus 1 is also equal to 1 by n summation modulus yk whole square, k being 0 to n minus 1. That means here what is the k mentioned? Here what is the k mentioned? 0 to 4. Okay, the summation mod yk square will be equal to n times, shifting the n on the other side, n times summation y square n. Okay, n equal to 0 to 4. Okay, so if I get yn, I can directly solve this expression, because calculating y xk then squaring it, calculating xk 5-point DFT will take time, little bit time it will take, na? Okay, but that can be avoided if you just apply the circular convolution property. Now, what is the circular convolution between the two? Okay, let me solve this here separately. Okay, circular convolution of xn and xn. What is xn? 2, 1, 0, 1, 0 with itself. Same sum by column method to be applied that you do for regular convolution. 2, 1, 0, 1, 0. Okay, first row multiplied by 2. Okay, so 2 to 4, 2 into 1, 2 into 0, 2 into 1, 2 into 0. Okay, next row multiplied by 1. Okay, so that means 2, 1, 0, 1, 0. But circular convolution also requires circular shifting. You cannot go outside this, write down the 0 here. Then next multiplied by 0. Normally we write down the result here, 0, 0, 0, 0, 0. The last two zeros should be here. Then multiplying by 1, result will start from here, 2, 1, 0, 1, 0. Bring this 0, 1, 0 here. Last row again multiplied by 0, 0, 0, 0, 0, 0. These 4 zeros will come up here. Now sum by column. Okay, now sum by column. 4, 5, 1, 4 and 2. This is the easy method to calculate circular convolution. Okay, I'll write down the result here. The circular convolution, that means yn signal is also obtained. 4, 5, 1, 4, 2. Okay, so the answer, n is 5 here. 5 times the summation of y square n, summation of all squares. So 16 and 25 and then 1 and then 16 and then 4. Okay, so this is 20, 45, 46, 62. Correct? Let me retally. 20, 21, 46, 62. 62 into 5, 320. Correct. 310, sorry. 62 into 5, no? 310. Answer should be 310 for this question. Done. Okay. So using Parseval's and the circular convolution property of the DFT. Big announcements for all of you that the GATE 2027 first offline batch date has been announced. Yes, you can see here the first offline batch for GATE 27 for ECEE. Okay, offline at our Hyderabad center starts 26th of February 2026. Okay, so as you know, in Hyderabad, one of the reputed offline coaching for GATE, is the OM Institute. So you can begin your, success journey for GATE with the OM Institute. Okay, you can visit our branch for more details, or you can contact 95156944053 for any details. If you are planning for, the offline batches for the AE exams of Telangana Genco Transco Discoms or AP Genco Transco Discoms, the new offline batch starts 21st of January. Okay, 21st of this month. And in case, for any reason, suppose you cannot travel to Hyderabad, okay, because offline batches will offer you, a very competitive atmosphere and a disciplined manner, and you'll be in front of the faculty throughout the year. So definitely you have that discipline and motivation going on. But for any reason, if you cannot travel to Hyderabad but still want the guidance from the same faculty, okay, by the same type of content, if you need same question level, same content level, you can also enroll to our online course. The first online live course starts 2nd February, which is available for gate 27 and 28, okay, as 1 and 2 years module. Okay, so for 1 year the fees is 1999 currently, and for 2 years the fees is 28,999. Okay, and if you register till 10th of January, you get additional 20% discount plus a 2 months extra validity. All right, guys. Okay.
So recently we have conducted All India mock test for GATE 2026 for both electrical as well as EC branches, and now we look at the solutions for digital electronics subject. Okay. Yeah, so this is a question that I have given from counters topic. Okay, the question is quite simple. So modulus is given and you are supposed to find out the minimum number of flip-flops. But I've used a small twist in the question, that is, I've given a modulo 500 counter and you are supposed to design this modulo 500 counter by using a combination of other counters, which are modulo 5 counter, modulo 20 counter, as well as modulo 10 counter. We don't have any limit in terms of the number of these counters that you can use ultimately to build your modulo 500 counter. So in that scenario, how many minimum number of flip-flops are required to design this kind of a counter? So that's the question. So what you are supposed to do is, you are supposed to now cascade these counters, the counters that are available to you, mod 5, mod 20 and mod 100, mod 10 counters. And for that we are supposed to factorize this number 500. So how can you write this 500 as? This is basically 100 into 5, which further can be written as this is equal to 10 square into 5. This is one way of factorizing it. One more way of factorizing this is basically 20 into 25 is also equal to 500. Furthermore, this 25 can be taken as 5 square. So this is 20 into 5 square. Okay, so we have two configurations of building this particular so-called modulo 500 counter. What are they? It is basically constructed by using cascade of modulo 5 counter, modulo 10 counter, and modulo 10 counter. We all know that whenever you cascade counters, the overall modulus is the product of modulus of individual counters. And if I cascade mod 5, mod 10 and another mod 10 counter, the overall modulus value is 500, which is the required modulus. Or one more way of getting that same thing is, okay, 20 into 5 into 5. So if you cascade a modulo 20 counter with a modulo 5 counter and with a modulo 5 counter again, so then also you get the overall modulus value as 500. Now let us count the number of flip-flops which are required for each of these individual counters, starting with modulo 5 counter. So we all know that whenever we have the modulus value as capital N, the minimum number of flip-flops required is ceiling of log of n to the base 2. Okay, so minimum number of flip-flops needed for, let's assume modulo capital N counter. So this becomes equal to, this is ceiling of log of capital N base 2, right? So in the first case we have modulo 5 counter. In the next case we have a modulo 10 counter. In the last case we have a modulo 20 counter. See, you have to work within the constraints. Sir, why can't I use this formula directly for modulo 500 counter? Because it's very clearly mentioned that you are supposed to design this only by using a combination of these counters. You are not supposed to design a modulo 500 standalone counter, not a separate modulo 500 counter we are designing. We are designing this by using the cascade of existing counters, which are 5, 20 and 10 counters. Okay, yeah, let's now plug in this value. This is ceiling of log of 5 base 2. This would be equal to 3 because log of 5 base 2 is 2 point something, ceiling value is 3. And for 10, it is log of 10 base 2. Log of 10 base 2 is 3 point something, ceiling value is 4. So this is 4. And for modulo 20 counter, this is ceiling of log of 20 base 2. Log of 20 base 2 is 4 point something, ceiling value is 5. Okay. Now when you count the number of flip-flops required, for modulo 5 counter we require 3 flip-flops minimum. So 3 plus, for 10 we require 4. So 3 plus 4 plus 4, answer is 11. And by using the other configuration for 20 we require modulo 20 counter, we require 5 flip-flops, and for 5 we require 3 flip-flops. So 3 plus 3. So here also we got 5 plus 6, which is equal to 11. So whether you go for this or this configuration doesn't matter. In both cases, the minimum number of flip-flops or the number of flip-flops required is basically 11. Okay. So hence the answer in this question is 11. Right? Yeah. So next we have this K-map. This is a very simple question. It's a 4-variable K-map and you're supposed to find out the minimized expression of this particular K-map. And if you look at all the options are given in terms of SOP format, and hence you are supposed to group the ones. Whenever you have this kind of a K-map, always first look at the corners, because corners can form one grouping. This is one group that usually are missed by students. So because of that, so focus on the corners first. Yes, corners actually can form one grouping. And what is the grouping now? This can be called as, now A is 1 here, B is equal to 0. So this is B bar. And C is equal to 0 when changing, D is equal to 0. So since D is 0, D bar. Next, all these ones can be formed as one single octet. So in this octet, CD are changing, so CD are eliminated. Whereas A is 1, A will remain, B is changing. So hence this will be taken as A because A is equal to 1. A is taken in true form. Ultimately, what is the answer now? The minimized SOP format is, so this becomes equal to A plus B bar D bar. Okay, I think which is equal to option A. This is a quite simple question. Nothing great we have in this question. Okay. Yeah, next. Yeah. Okay. Even though this is given for 2 marks, the question is a very, very easy question. Okay. Usually I can also put it in 1 mark category, but the reason why I've put this in 2 mark categories, just to understand, first of all, a lot many students will not be able to understand the question. So the marks here are mainly for going through that particular phase, read the question, understand the question, and try to answer the question. So if you are simply scared after reading the question, and if you're not able to let's assume understand what the question means, you are losing on very simple 2 marks here. Okay. So there are 3 coins here which are namely A, B, C. So A is the first coin, B is the second coin, and C is the third coin. And logical variable 1 represents heads of the coin and 0 means tails. The logic function f is 1, that is output is 1, we can say, if exactly or only one of the coins is head after a toss of the coins. You have tossed all the coins, and if only one of the coin is basically head, then we have output value as 1. So means, let me take A, B, C here. Okay. So we have 3 scenarios where the function value becomes 1. What are the 3 scenarios? Head, tail, tail. Or ABC equal to tail, head, tail. And again ABC equal to tail, tail, head. Okay. So in all these cases, the function value becomes equal to 1. Now let's convert them into logic values. In terms of logic values, what do we have? Head means logic 1. So means 1, 0, 0. Tail means 0. So 0, 1, 0. And lastly, we have 0, 0, 1. So in all these 3 cases, the function value becomes equal to 1. Now, the combination of ABCs for which function value is 1 can be called as minterms. And now all you have to do is express the minterms in the form of expression. Okay. So hence function of ABC now can be written as, in case of minterm, 1 means variable is taken in true form, 0 means variable is taken in complement form. So first we have 1, 0, 0 means A in true form, B, C in complement form. So A, B bar, C bar. Next we have 0, 1, 0 means B in true form, but A as well as C both are taken in complement forms. Lastly we have 0, 0, 1. So A complement form, B complement form, C is in true form. So I think which matches with option B. Okay, option B is A true form, B complement form, C complement form. A complement form, B true form, C complement form. Yes, second one. The last one is A bar, B bar, C, which is basically matching with the given scenario. Like I've told, the question is quite simple. You have to cross that barrier of Okay, let me read the question, try to understand the question. The data is not given in the form of truth table, not given in the form of directly min terms. So you have to get the min term expression of this particular function, and by using the given data. So that's the main goal here. Okay. Yeah. Next. Again, a question on state machines. Okay. Or I would say a question on sequential counter design, sequential circuits, counter design mainly. So here we have some clocked sequential circuit, okay, and given this clocked sequential circuit, if at all we have the present state, which is q1 q0 being equal to 1 0 and x is equal to 1, then the state q1 q2 and the output y after the clock edge. So we have to understand that this is the information given to us before the clock edge. Yeah, so this information is basically before the clock edge. So after the clock edge, definitely your state changes and accordingly your output also will change. You are supposed to find out now new state as well as new output values after the clock edge. Okay. So for this, whenever you have questions of this particular format, all you have to do is construct your state transition table. So what are the contents of your state transition table? You'll have a present state, the present state as well as your external inputs. Okay, in this case, external input is equal to x. Will decide what are your present inputs, which are D1, D2 here, and the present inputs as well as your present state combinedly will decide what is your next state. And if you look at the circuit, we will see also shortly again, the next state will decide what is the value of your new output value. Okay. So what is your present state? Present state is Q1, Q2. I think the notation is here, Q1, Q2 notation. And the external input given to us is X value. So we have, I think, some external input X here. And the present inputs are D1 as well as D2. Write this D1, D2 here itself in the form of expression. This is D1. This is Q1 means this is obviously D1. Examiner need not mention it for you in the diagram. That is by default implied. So this D1 becomes what? One of the input is coming from where? It is Q2. One of the input is basically coming from Q2. The other input is coming from Q1 bar, complement of Q1. So this is Q1 bar. Some people do the mistake of cancelling out this complement and the bubble. Don't do it. This is just given for extra information. Okay, just because you have been shown a bubble here does not mean that you have to again complement this particular bar and remove the bar and bubble. Don't do that. That is a silly mistake. Obviously, a flip flop will have two outputs. One is output in true form. The other is output in complement form, right? So if this is Q1, this would be obviously Q1 bar. Output will be Q1 bar. So that's what we have taken here. So you are adding both of them. So this is Q1 bar plus Q2. And what is the value of D2? This is D2. D2 value is AND of two things. One of the thing is basically your Q2 bar. So it is equal to Q2 bar multiplied with what is the other input? The other input is basically coming from X. Okay, multiplied with X. Now combinedly your present inputs as well as your present state will decide what is the value of next state Q1, Q2. And finally, what is Y from the circuit? From the circuit, if you see, Y becomes equal to, it is logical addition of two things. One is, what is one? Yeah, one is basically your Q2 bar and one more input is basically Q1. So this is Q1 plus Q2 bar, right? So this is your overall table. Now let's take the initial values. The initial values Q1, Q2 is 1, 0 and X is equal to 1. So this is 1, 0, X is equal to 1. That's it. Now I don't even have to look at the diagram. I can directly answer the question directly from here itself, from this table itself. Q1 bar. What is Q1 bar now? This is 1 bar plus Q2 is equal to 0. So combinedly, how much is this value? 0. What is your D2? D2 is equal to Q2 bar. Q2 bar means 0 bar multiplied with, logically multiplied with, yeah, what do we have? Multiplied with 1. So, 0 bar is 1, 1 into 1 is equal to 1. So, since your D1, D2 is equal to 0, 1, your Q1, Q2 after the clock will become equal to 0, 1. What is the value of y? Y becomes equal to q1, which is 0, plus q2 bar, which is 1 bar. So 0 plus 1 bar becomes equal to 0. That's it. I've got my q1, q2 as well as y new values. So q1, q2 after the clock edge new values becomes equal to 0, 1, and the value of y again new values becomes equal to 0. Okay, so these are your contents. Let's verify. Q1, Q2 becomes equal to how much? 0, 1, and y should become equal to 0. Okay, which is happening in option A. Apart from that, we also have that circuit being called as Moore state machine. Is it correct? Also yes. Okay, this is definitely a Moore state machine. Why is that so? Because as you can see here, y is a function of only the present states. I can clearly notice that from here, y is function of only the present state, okay, or the next state simply. But y is not a function of external inputs. In this case, who is the external input? X. It's not a function of x. So whenever we have output being a function of only the state, but not a function of present inputs, we call it as basically Moore state FSM. Okay. So whenever this is satisfied, we call it as basically Moore state FSM. Okay, what happens in Mealy FSM? In Mealy FSM, your output becomes also a function of inputs, the present inputs, which is nothing but external inputs x. But that kind of a scenario is not there in the given problem, so because which this is basically a Moore FSM, wherein output is a function of only the state. Okay. Yeah, so this is this question. Next we have a dual line mux. Okay. So a dual 4-1 multiplexer is given wherein CD are connected to MSB and LSB pins of select lines of multiplexer. The CD lines here are not shown, but you know the information is specified in the question itself. So you'll have a C here and you'll have a D here, MSB1, LSB0. Okay. So C is connected to MSB and D is connected to LSB pins. Then which of the following is a minimized form of FB? FB, wherein this is nothing but your FB. That is for the second output. The second output is a function of your second input lines. So these index number 2 lines will decide what is the value of your 2y. We have 2y, 2y is a function of 2a. Similarly, your 1y is a function of your 1a apart from obviously your common select line. So for the first half and the second half of the multiplexer, the select lines are common, which are nothing but CD, wherein C is MSB and D is LSB. So given this, first of all, we are supposed to write the expression for FB. Let me do that. What is the expression of FB now? This is C bar D bar into data input 0 plus C bar D data input 1, CD bar data input 2, CD data input 3. Okay. What is the data input 0? Connected to 0, we have 1. So this is 1. Next, we have connected to 1, we have a 0. So I'm taking a 0 here. And then connected to 2, we have A bar B. I'm taking here A bar into B. And connected to 3, we have A bar. And hence we are taking this A bar. That's it. So let's write this in terms of, first of all, product format. And later on, we'll write this in terms of minterms format. So first one, C bar, D bar. Second one is gone, 0. The next one is A bar, B, C, D bar, plus lastly we have A bar, C, D. Now let's convert them in terms of minterms format. In terms of minterms, AB is not there, X, X, C and D both are in complement form and hence zeros. So double X 0 0 corresponds to what? X 0 0 means 0, 0 1 means 4, 1 0 means 1 0 0 8. 1 1 corresponds to 1 1 0 0, this is 12. And whereas this is 0 1 1 0, index number is 6. Whereas this is 0, B is not there, C, D are in true form 1 1. If at all there is a missing variable, we take X. Here AB are missing, order is A, B, C, D. So AB is missing and hence I've taken both of them as XX. And I've taken all 4 combinations of XX. XX can be equal to 0 0. If it is 0 0 0 0 0 0 is nothing but decimal 0. 0 1 if you take x as 0, 1, you'll have 0, 1, 0, 0, which corresponds to 4. If you take 1, 0, total will have 1, 0, 0, which corresponds to 8. 1, 1 are the values of x means 1, 1, 0, 0, 12. And here anyway, we have all 4 numbers. And here we have to take x is 0. If x is 0, 0, 0, 1, 1, which means 3. If x is 1, 0, 1, 1, 1 is nothing but 7. So we have this now min terms representation of function sigma min terms 0, 3, 4, and then 6, 7, 8, and lastly 12. Okay, I think all min terms are accounted for 4, 5, 6, 7, total 7, 1, 2, 3, 4, yeah, 7. Now, lastly, you are supposed to construct the K-map for this. I'm constructing a 4 variable K-map here with variables same order as we have taken here, A, B, C, D order. And you should know the cell number beforehand while populating this K-map. Okay, the cell numbers are 0, 1, 3, 2, 4, 5, 7, 6, 12, 13, 15, 14, 8, 9, 11, 10. That is the cell number order. Right now we have 0. In cell number 0 we place a 1 because min terms are function values being equal to 1. Then 3, 4. This is cell number 3, this is cell number 4, 6, 7, 8, 12. Okay, remaining cells are filled with what? Zeros. So now let's form the groupings. One of the grouping could be this. I can see a nice quad here. And then I can take a pair like this. And lastly, I can take another pair like this. That's it. What is this grouping known as? This is basically C bar, D bar. And this grouping is equal to, in this grouping, we have CD is equal to 1, 1, C into D. Apart from that, A is 0, hence A bar. And this last pair becomes equal to AB is 0, 1. So this is A bar B. And furthermore, in the first and last columns, D is equal to 0, C is changing. So since D is 0, we are taking it as D bar. That's it. So I've got the minimized representation of this function. So the minimized representation of this function is F is equal to FB is equal to, now the minimized format, we have C bar D bar plus A bar CD plus A bar B D bar. That's it. So let's cross verify with the options. We have C bar D bar. I think, where do we have C bar D bar? I think in option B and D. I think most probably the answer would be B because we have A bar CD. Do we have A bar CD? Yes. And we also have A bar. Okay. So see the last one, this one, there are two ways of covering this one because I'm just going with the option. The option does not have this term. So if you see here, already all the ones are covered except one guy, this one. I can cover this one by forming a wraparound pair or by forming a pair something like this. And if I form a pair like this, we have A0, A bar, B1, B, and C is equal to 1. So C. And all I'm doing is nothing but I'm replacing the last guy. Okay. So the last one is what? Now this is A bar, B, C. There are two ways of doing it. There could be two possible solutions for this question. Please mind. It can be a very well MSQ question too. Okay. So yeah, A bar, B, C is what we have. And hence the answer is B. See, again, this question involves getting the output function first, and the output function will be in terms of SOP. And after that, you have to convert that function in terms of min terms format. Using that min terms format, you are supposed to construct the K-map, group once, and finally get the answer. So, the question is quite simple, but since we have more number of steps, yeah, the question is given as a 2-mark question. Okay. But yeah, definitely routine question wherein you have questions on multiplexer. This is an analysis problem of multiplexer. They'll give you some kind of a circuit like this, multiplexer circuit, and they'll ask you what is the value of output function, either in min terms format sometimes, or sometimes they will ask you what is the minimized expression of output, or sometimes they will ask you design problems wherein, if at all, this is the output that I require, this is the function that I require at the output side, then what should be the data inputs here? Okay, so that could be one more question. So be cautious. This is a very routinely asked question in GATE exam. Okay. Okay, so next we have here a 4-bit D2A converter is connected to a free running 3-bit up counter. So we have a 3-bit up counter as shown. So if at all we have a 3-bit up counter is this guy. Okay, where is this? Yeah, this is the 3-bit up counter. So please note that whenever Q2, Q1, Q0 is equal to 0, 0, 0. So in this case, what is D3, D2, D1, D0 doing? Okay, so you can always construct this table first. For a particular combination of Q2, Q1, Q0, what are the values of D3, D2, D1, D0? Because D2, if you notice, is always at logic 0. Okay, so this is always at logic 0. So I'll start, since it is up counter, we'll have 0, 0, 0. So Q2 is connected to D3. So because which this is 0, this is always by default 0. Okay, so 0, 0, 0. If this is 0, 0, 1, this also becomes equal to 0, 0, 1. 0, 1, 0 up counter, 0, 1, 2, 3 order, 0, 1, 0, 0, 1, 1 means 0, 1, 1. 1, 0, 0. Now is where you'll understand the difference. This becomes equal to 1, 0, 0. 1, 0, 1 means again 1, 0, 1. 1, 1, 0 corresponds to 1, 1, 0. Lastly, triple 1. If I take triple 1, this is again triple. Okay. Now look at the decimal values of all these guys. This is 0. All zeros, 1 is 1. This is 2. This is 3. After 3, what is 1 triple 0? 8. 1 0 0 1, 9. 1 0 1 0, 10. 1 0 1 1 is 11. So 0, 1, 2, 3, we are going in step fashion. But starting from 3 to 8, we are making a jump. Okay, so that's how it should be. You're starting from 0 and then 1 and then 2 and then 3. You're making a jump. You can understand that this jump is equal to now 8. Okay, 8, yeah, 8 and then 10. This is 11. I can assume that this is 12. But after 12, where do you go to? After, let's assume triple 0, your next state would be again after triple 1, your next state would be triple 0, right? Because this is a 3-bit up counter. You have a 3-bit up counter. So in up counter, after all ones, you'll have next state as nothing but all zeros. So then after 11, where do you end up? You'll end up at state 0. So is it happening here after 12? Are you going to 0? No, you're going to the previous state, which is nothing but, if I call this as 11, so this also becomes equal to now 11. So definitely option A is wrong. Okay, option A is wrong because of this. This cannot happen. Okay, until here it is proper only. This is completely wrong because you are going in what manner? In a ramp fashion. 0, 1, 2, 3, 4, 5, 6. Some numbers I'm having a ramp fashion. I cannot have ramp fashion. Okay, because after 3 you are making a sudden jump to 8. Now look at this again. Are we having that 0, 1, 2, 3, and then if you see you are having a sudden jump here, maybe here also you can see 0, 1, 2, 3. You are making a sudden jump. I can assume that that sudden jump is 8, and after that 9, 10, 11. After 11, where you are coming back to again, you are coming back to the state 0. So definitely this is the correct option. So option B is the correct one. Okay, so it's all about understanding the waveform from the given circuit. Okay, and what about this guy now? Here we are going in linear fashion, again coming back in linear fashion. We cannot have any linear fashion increase. There should be a sudden jump, and that sudden jump is not observed here. D is not the correct answer. Okay, yeah, so this is about the digital electronics. Okay, thank you. Okay, so now we look at questions on EMTL. So we have a total of 6 questions here. We have 3 1-mark and 3 2-mark questions. Okay. Yeah, the first question is from vector calculus. We have a line integration question. So a vector field f bar is given and you are supposed to find out the value of integration over a closed path. Okay. So obviously circle. What is a circle? Circle is basically a closed path. Okay. So hence this is a question of closed path integration. Okay. Now what is the radius of this circle now? I can see that x square plus y square is equal to 1. So means radius of this circle becomes equal to 1. So you are evaluating this line integration over a circle whose radius is equal to 1. In what direction? Anti-clockwise direction. So this direction is pretty important. Because the path is present first of all on xy plane, so you have to know what direction of differential surface you are supposed to take. Okay, whether it is plus z cap or minus z cap. So for that, this direction is quite important. So since this is entirely present on xy plane, this entire path is given to you on xy plane. What is the value of differential surface area that we take? Differential surface area is having some magnitude ds, but what is the direction? Direction is either plus or minus z cap. But I'm taking specifically plus z cap. Why? Because the direction of the orientation of the path is basically anti-clockwise direction. So we have a circle oriented in this direction. This is x-axis, this is y-axis. And coming out of the board plane will be nothing but your z-axis. When you curl your fingers in the direction of the given path, the thumb point out in what direction? Plus z direction. And hence I'm taking here plus z cap direction. Okay. So this is your path C. So ultimately here I'm supposed to calculate what? Closed path integration of f bar dot dl bar, my notation. So we can use Stokes theorem. By using Stokes theorem, we can write this as integration of del cross f dot ds bar. So always calculate curl first, because sometimes you will get curl as constant, like in this case. So whenever you get curl as constant, you can always simply take integration of surface area or integration of ds, and the result becomes equal to surface area. So when you calculate curl here, del cross f, this becomes equal to how much? This is z cap. Okay, z cap dou f y by dou x minus dou fx by dou y. Or you can also use Green's theorem here. Both are one and the same. Green's theorem is special case of Stokes theorem applied only for xy plane. Okay. So this is equal to z cap. Yeah. What is the y component? This is the y component. You have a constant 1 by pi anyway. So this is fy and this is fx. Okay. Differentiation of fy with respect to x, we have x term here, and hence this becomes 1 minus cos y minus differentiation of x component, which is fx, minus sin y with respect to y will give you what? Differentiation of sine with respect to y is cos. So minus cos y. Minus minus is plus. Minus cos y plus cos y. Both are gone. I think you have a constant 1 by pi. I'm taking that 1 by pi here. So hence this becomes equal to z cap into simply 1 is left out here, 1 by pi. Okay. Luckily we have got the curl expression as a constant here. Substitute this here, and what do we get? We get this as integration of z cap 1 by pi. From the information of path, we have got ds bar as basically some ds. Direction is z cap. So z dot z becomes how much? That becomes equal to 1. And 1 by pi I'm taking outside. Integration of ds becomes equal to surface area. Which surface area? Surface area enclosed by this particular closed path. And is it not basically the area of the circle? Yes. What is the radius of the circle? It's equal to 1. So hence this becomes equal to 1 by pi into 1 square, which is equal to simply pi by pi becomes how much? 1. The overall answer in this question is how much? It is equal. That's it. Very simple question. Okay. An application of Stokes theorem. Okay, so we'll go for the next one. This is a good question. I've given this as MSQ. So if you look at here, there is a 50 ohm transmission line. This is a 50 ohm transmission line terminated by a load ZL. What is the information of ZL? We don't know. The load impedance has a resistive as well as also your reactive parts like shown here. Now it is shown that when seen from load end of transmission line, we have V max, voltage maxima, where at 5 centimeters. Okay. And then we have a V min where at 10 centimeters. So distance between a maxima and minima is how much? It's basically equal to lambda by 4. Okay. So V max or we can directly take the line only. One of the V max is where at x is equal to some, I think, 5 centimeters from the load end. Yes, and then V min where at x is equal to 10 centimeters. Means if you see the distance between maxima and the next minima becomes equal to some 5 centimeters. Okay, so this is basically distance between them is equal to 5 centimeters. Now when I move away from this location of maximum, what will I get now? I'll get another minima. So because of that, on the basis of this information, I can say that we have another V min, because after every 5 centimeters we'll have an extremity. So if at 5 centimeters we have a maxima, at 0 centimeters we'll have a minima. Okay, and after 10 plus 5 again is 15. At 15 what do we have? We have another next extremity is what? After minima you'll get a maxima again. So V min occurs basically where? At x equal to 0. So at x equal to 0 means what? At exactly load end of transmission line. So it means that at load end of transmission line, exactly at the load end of transmission line, we have V min. V min occurs. In how many cases we'll have voltage minima exactly at the load end of transmission line? In 2 cases. What are they? Either in case of short circuit transmission line, or in case of resistive load where resistance is less than Z0 value. Okay. One more case is resistive load scenario where resistance is basically less than the characteristic impedance of transmission line. That's it. This is the logic. So for a short circuit transmission line, what is the value of resistance and reactance? Both values should be equal to 0. So this corresponds to the short circuit transmission line. So is this the correct answer? Yes. And if you see, A is not the correct answer because this is not R load. This is neither R load nor short circuit transmission line. So option A is gone. What about this? Is it not a resistive load, purely resistive load? Yes. So in this example, we have R load. What is the value of resistance? 25. Is it not less than Z0 value? 50? Yes. So, and R value is also less than Z0. So this is also a possible case where the current problem or current data given to us matches. And even here, if you see, even in this case, what is the condition that you have? Reactance is 0. So hence this is purely resistive load where resistance value R is less than the characteristic impedance of transmission line. So even B is the correct answer. The correct answer is B, C, D for this particular question. Okay. Yeah. Next. The electric field of a light wave is given by so and so expression. Yeah, this is again a question on polarization. Given the wave, you are supposed to identify what kind of polarization we have. Here, I always give one method. If you follow that method, the way of finding out this polarization becomes quite easy for you. So you always start by identifying what is the direction of wave propagation. So from this, I can clearly notice that the wave is propagating in what direction? When you have minus Z there, wave propagates in plus Z gap direction. Wave propagates in plus Z cap direction. So this is step 1. Now you write this Z cap as cross product of 2 other vectors, 2 perpendicular vectors. Now here, both of them are sign terms. This is something that you have to cross verify every time. This is I cap and this is J cap. So I can write my Z cap as what? Is it not X cap cross Y cap? Yes. So this becomes your first component. This becomes your second component. So now find out something called as phi. Phi is phase lead off. This is phase lead off the second component with respect to the first component. And how much is that? The second component, how much is the phase angle? Omega t minus kz, omega t minus kz. If that is gone, the extra phase term that you have is minus pi by 4. Okay, there is no other extra phase term here, minus 0. That is the phase lead, the phase angle of the second one with respect to the first one, which is y component. Y component is nothing but this is your second guy, and x component is the first guy. So the phase lead of the second term with respect to first term is what you are supposed to find out. So phase angle of the second term minus the phase angle of first term. So which is how much? Minus pi by 4. So technically we don't have any phase lead, we have a phase lag. So but still the phase lead, okay, of the second with respect to first is negative, is what we can notice. And this angle is neither 0 nor plus or minus 90. So this number, which is 45, is not 0, not 180, okay, not plus or minus 90. So hence, if it is 0 or 180, we will straight away say ki, this is basically linear polarization. If it is plus or minus 90, then we'll compare the magnitudes. Magnitudes, if they are same, we can call them as either right circular or left circular. So none of that conditions exist. So due to that reason, we can say ki, because of this, the polarization is basically, the polarization is elliptical. Okay, this is elliptical polarization. But what kind of elliptical polarization? That depends on the sign here. If you have a negative sign, this becomes right elliptical, and if it is positive sign, it becomes left elliptical. So since minus sign we have, this is right-handed. So overall answer is what now? This is right-handed elliptical polarization. Okay, so the overall answer is right-handed, elliptical polarization, right? So this is all about 1 mark questions. So all questions are quite simple. Let's go for the 2 mark question. Even though I put this in 2 marks category, okay, people who know the logic hardly would spend 30-40 seconds of time on this question. But people who don't know the logic, they may easily waste almost like maybe 8 to 10 minutes of time on this question. Because I'm asking you to identify which of these expressions are basically waves. Okay, describe waves basically. That's it. Traveling waves, standing waves, not our headache. Waves, some kind of a wave. Now, one way of solving this question is by substituting this in the wave equation. What is the wave equation? Okay, the wave equation is basically, since all of them are given in terms of only x, dou square so-called wave by dou x square becomes equal to 1 by velocity square dou square wave by dou t square. So if at all an expression of psi satisfies this condition, we can call that as wave. Or one more way, that's what I told. One way of solving this question is by cross-verifying the option whether it is satisfying this condition or not. But clearly you can notice that it would take a huge amount of time on the basis of the given data. Okay, the way the data was given, it would take a enormous amount of time to do these calculations. One more way. What is the other way? A wave will be second order function minimum. Okay, but given in terms of, which can be expressed in terms of f of x plus or minus vt. That's it. So verify in which of the following options you're having the function given in terms of x plus or minus vt. First one, is it given in terms of x plus or minus vt? Yes. Second order term, also yes. So this is function x plus or minus vt. In fact, it is x plus vt format. How much is the value of v here? V becomes equal to 1. X plus vt, where the wave velocity becomes equal to 1. So is it a wave? 100% yes. We don't have to substitute this in this expression and do the calculation. You can do it after the exam also if required. Okay, but please note that the moment you can write a second order term in x plus or minus vt term, vt format, then that definitely is basically a wave. Okay, what about this? Can you write this in x plus or minus vt format? No, we cannot write this as f x plus or minus vt. So is this a wave? No, this is not a wave. Okay, what about this? Again, I can write this as this is f of x minus vt format, wherein the value of velocity, wave velocity becomes equal to, in this case, 1. So is option C a wave? Yes. What about here? Again, can I write this ax plus bt as this format? Yeah, I can. You can notice here, if I take a common here and throw it outside, we'll have a square. Then we have x plus b by a times t whole square. So again, is it not some kind of f of x plus vt format? Yes, wherein in this expression v becomes equal to b by a. Is it a second order term? 100% this is a second order term. So even option D is a wave. Okay. So we have three options which are waves. The logic here is what? Whenever a function can be expressed in x plus or minus vt format, means this x plus vt, if it can be replaced by some other variable, in this case I can replace this x minus t by means of maybe some other variable z, let's assume. Okay, and this is overall what? A naught by b z square plus 1. So can I call it as a wave now? Yes, because I can express it as some other variable z. Here I cannot take a z where that z becomes equal to x plus or minus vt, because the term here 2ab x square t, whatever is the term that is missing here. So due to which we cannot, no matter whatever you try, you cannot write this basically as x plus or minus function of x plus or minus vt term. And hence this 100%, you don't even have to, if you want you can always cross verify it in this expression, okay, but you don't even have to do that. That's what I mean to say. That's the intention behind this question. Whenever you see any expression written in this format, wave, if it is not a wave. One more condition is there, that is it has to be a minimum of second order term. Okay, it should be a minimum of second order term, then only you can call it as a wave, right? Yes, let's proceed. So this is a question on waveguides. So here we have Ez given to us, which is a non-zero value. Okay, so what is the value of Ez here? Ez becomes equal to some non-zero value, and I can say that in this case Hzs becomes equal to 0. Okay, so the magnetic field is not present in z-axis. So when magnetic field is not present in z-axis, this becomes Tm mode. So because of this, we can say that this is Tm mode, transverse magnetic mode, because magnetic field exists only on xy plane, okay, only in x and y directions, but rather not in z direction. So that completes 50% of the problem. So the answers are not basically B, neither the answer is A. Now this coefficient is there, this becomes equal to m by A. Okay, so usually m pi by A, and this m pi by A becomes equal to 20 pi. So do we have the dimensions of this waveguide? Yes, A value is given as 5 centimeters. So this is m pi by 5 centimeters, 5 into 10 power minus 2. I'm writing everything in terms of meters here, 20 pi. So pi as well as pi is gone. So from this, what is the value of m? M becomes equal to 20 into 5 is 100, 100 into 10 power minus 2 is 1. So we have got the first mode, the x direction mode as nothing but 1. 50 pi, okay, so that 50 pi now is n pi by b. N pi by b becomes equal to 50 pi. Pi as well as pi is gone. What is the value of b? B is equal to 4 centimeters, 4 into 10 power minus 2. And from this, what is the value of n? N is equal to 50 into 4, 200 into 10 power minus 2, 2. So the usual expression of mode number is basically Te or Tm. That is Te or Tm, small m, small n, small m, small n. Wherein the mode number m corresponds to number of half cycles we are having in x direction. Small n corresponds to number of half cycles we are having in y direction. So anyway, we have ruled out T mode here anyway. The answer is Tm mode. What is the mode number now? M value is equal to 1, n value is 2. So this is overall Tm 1-2 mode of operation. Okay. So I think the option is, correct answer is option C. You have got these kind of questions multiple times earlier in exams. In waveguide, if at all you are having a question, you will have questions only on 2 formats, in fact 3 formats I should say. One is this kind of a scenario. They'll give you some expression and they'll ask you to identify the mode number. Okay. One more kind of question is cutoff frequency questions, and the last type of question is the intrinsic impedance question, both in TE mode as well as TM mode. That's it. So these are the 3 most commonly asked questions in waveguides, right? Yeah. Next, this is a question on antennas. We have the distance between the transmitting as well as receiving antenna. I'll discuss this question slightly in a different format. In fact, we'll derive this expression also. The question is basically from Friis transmission formula. Okay. So in case of Friis transmission formula, all we have is some antenna. So I'm having a transmitting antenna here. Okay. So this is my transmitting antenna. So I'm having my receiving antenna very far away. This is my receiving antenna. So it is basically taking some power. Okay, so this is the power transmitted by this particular transmitting antenna. So given this power transmission, how much amount of power you can receive at this location is nothing but the so-called Friis transmission formula. So for a particular value of PT, what is the value of PR, provided the distance between both of these guys is, let's assume capital R. Okay. Yeah. So this concept requires only three sub-concepts. The first is basically power becomes equal to power density into area. Point 1. Second point is nothing but the actual power density is equal to isotropic power density into gain. This is one more thing. And the concept of effective area of an antenna. The effective area of an antenna is given by a small formula that is given by gain GD times lambda square by 4 pi. Okay, so this is the so-called effective area of a particular antenna. Usually the antenna effective area is not its physical area. It depends on its corresponding gain. If gain is more, obviously we can absorb more amount of power and hence the so-called effective area is more. Okay, so that's the meaning of this so-called effective area. It is not the physical area of antenna, please note. So the moment you understand these three things, no, very simple things. How much amount of actual power you are transmitting in a particular direction, that becomes equal to isotropic power. The reference case, okay, if let's assume power is uniformly flowing in all the directions, how much power density I'll have? Isotropic power density. And since I'm channelizing my energy in one direction more, I'm having a gain there. Okay, so technically this is basically channelizing the power. What is this gain? We are not giving some extra power to that particular antenna in a particular direction. The power remains constant. This power PT will not change. We are not increasing the value of PT. We are not amplifying the power here. But we are channelizing this power in one single direction towards the direction of receiver. Okay, so because of that, the power looks like it is getting amplified, but rather it is basically channelizing the direction of the power from other directions into this particular direction, and hence we call it as also directive gain. Okay, so if this is basically the total power transmitted, now how much is isotropic power that you will have, isotropic power density that you will have at the location of receiver if the gain is 1? It is total power by total area through which this entire power is flowing. So in case of antennas, the power is flowing in all the directions. Okay, so due to that, it is flowing through a big sphere of radius r, this r, and hence the power density is given by the surface area of a sphere is how much? 4 pi r square. This is the isotropic power density. Now, how much amount of power density now is available in the direction of receiver? So that is basically power density at the receiver. At Rx becomes how much? This is isotropic power, this logic. Isotropic power into the gain. Whose gain? Transmitter's gain. So this is PT by 4 pi R square into GD of transmitter. So this is the power density that is available at the receiver. How much amount of power you are absorbing? That becomes equal to the received power. The received power is equal to the power density that is available, okay, at the receiver multiplied with the effective area of that particular receiver. So hence this is equal to how much is the power density that is available? Transmitted power by surface area, isotropic power density multiplied with the gain of the transmitter, which corresponds to the so-called power density term that is available at the receiver, multiplied with effective area. What is effective area? This is lambda square by 4 pi into the gain of the receiver. That's it. So this is your overall expression. 4 pi becomes 4 pi square, r square, lambda square. I can combine all of them into one single bracket term. We'll have lambda by 4 pi r whole square into GDT, GDR, PT. That's it. That's the overall expression. Okay. I just want to show that this is a very, very simple topic. Okay. This Friis transmission formula. Don't mug the formula. More than mugging up the formula, try to understand the logic so that you feel that this is very easy. Okay. So overall, we have received power to be equal to transmitted power into the gain of transmitter into the gain of receiver into lambda by 4 pi r whole square. Now let us substitute all the values. What is the value of your r? In the question, r is given as 200 times lambda. The distance between the transmitter and receiver is 200 times lambda. So this is 200 lambda. Okay. Yeah, gain of the transmitter. Both gains are given in terms of dB gains. So given this, you are supposed to find out the absolute values of gains. So have the transmitting antenna 25, receiving antenna 18. So the gain in absolute terms, this becomes equal to 10 power dB gain by 10. So which becomes equal to 10. If I take for, let's assume transmitter gain is how much? I think 25. So this is 25 by 10. So this is 10 power 2.5. And the receiver gain is how much? 10 power 18 by 10, which is equal to 10 power 1.8. So these are the numbers. Okay, we can plug in those numbers here directly. And it was told to us that the receiver power should be how much? This should be greater than 5 milliwatts. The power that is supposed to be received should be a minimum of 5 milliwatts. Means it should be whatever is the actual number, it should be more than that. It is more than 5 milliwatts becomes equal to, what is the transmitted power? I don't know yet. I know the gains I have, which is equal to 10 power 2.5, and this is 10 power 1.8. And then overall, this ratio is how much? I think 1 by lambda is gone, 800 pi whole square. So finally, the value of PT should be more than 5 into 10 power minus 3 into 10 power 2.5 into, sorry, you're sending it on the other side now. The numerator term would be 800 pi whole square divided by 10 power 2.5 into 10 power 1.8. So this should be the minimum power that you are supposed to transmit. So let me put these numbers in the calculator. Okay. We have I think I've got the answer. It's 1.58. 1.58 watts of power. Okay. So let me I think 1.58 is the correct answer. Okay. So this is what you have regarding your EMTL subject. So I have given the questions in such a way that I've covered all the topics. We have a question on antennas, we have a question on waveguides, we have, I believe, one question on EM waves, a couple of questions on transmission lines, one question also on the vector calculus portion, etc. Yeah. So this is all about EMTL, and all the best for your exam. Do well.
Alright guys, now let's look at the questions from EDC. So here's the first question. What is it? Identify the correct statements, and this is what MSQ. So 4 different statements are given. You just have to identify which statements are correct. Okay. So let us look at each of the 4 statements one by one. this is a small typo. In a P plus N junction, P plus N, it means what? P side is more heavily doped compared to the N side. It is also what? A one-sided junction. The current meaning what? The current through the PN junction, which is what we call the diode current, is inversely proportional to the level of doping on the N side. So the statement is telling that ID, the diode current, is proportional to 1 by ND. Is actually true, but let me explain. You say the diode current is the sum of the hole injection current and the electron injection current. And in a P plus N junction, the forward current is primarily due to what? The injection of holes from P side to N side, because P side is more heavily doped compared to what? N side. So definitely IP will be far greater than IN, in which case IP plus IN is nearly equal to what? IN. So what is the diode current? It is nearly equal to what? IP itself, which is the hole injection current. Now what is the expression for the hole injection current? It is AQ dP Pn naught by Lp, and then you have that exponential factor, which is e power Vf by Vt minus 1. Now in this expression, what is this Pn naught? Pn naught, is it not the thermal equilibrium minority carrier concentration on the N side, which is equal to what? Ni square by Nn naught, where again Nn naught is what? Nd. So in place of Pn naught, you can write Ni square by Nd, correct? So in place of this Pn naught, you can write Ni square by Nd. Then the same diode current can be written as what? AQ dP, and then, sorry, is there an undo option here, or is there an eraser? Okay, eraser is there. Pen. AQ dP Ni square by Lp times Nd, and then e power Vf by Vt minus 1. So clearly ID is what? Inversely proportional to Nd, and that is what the statement also is telling us. So the statement is what? Correct. Okay. So ID is proportional to what? 1 by Nd. So the statement is correct. We'll look at the second statement, which is option B. So let me read it out. In a P plus N junction, again we have what? A P plus N junction. The junction capacitance means what? Cj increases with an increase in the level of doping on the N side. Again, level of doping on the N side is what? Nd. So what this statement is telling us is that the junction capacitance is directly proportional to what? Nd. Or if not directly proportional to Nd power 1, what it means is, if Nd increases, they are saying Cj also will increase. Okay, let me write it that way. Because they are not telling that Cj is directly proportional to Nd power 1. All they are saying is, if Nd increases, Cj also increases. That is what is implied by the statement. Let's find out if this is correct or not. Again, what is a junction capacitance? It is due to what? Charge storage in the depletion layer in the form of positive and negative ions on either side of the depletion or either side of the junction. What is the other name for junction capacitance? It is also called depletion capacitance. Okay. And how do you remember the junction or depletion capacitance? You should remember it as a parallel plate capacitor, where the distance between the two plates is equal to what? The width of the depletion layer. So we all know very well. So Cj is what? Epsilon Si times A. A is what? The area of the junction divided by the distance between the two plates, which should be taken as what? The width of the depletion layer. And we know W depth. What is W depth? Given by square root of 2 epsilon Si times the net voltage across the depletion layer divided by Q times N effective. Now again, for a P plus N junction, where N side is what? The lightly doped side, the effective doping density is nothing but the level of doping on the lightly doped side, which in this case is what? Nd. So in place of N effective, you can actually write Nd. So this N effective, it is what? Nd. Okay. So it is quite obvious, when you increase Nd, this denominator increases, the width of the depletion layer will decrease. When W depth reduces, Cj will definitely increase. I think this statement is also correct. Yes, Nd increases, Cj is increasing. So option B is also correct. Even the earlier statement, it is correct. Even B statement is correct. Let's look at the next statement, which is option C. In a P plus N junction, again P plus N junction, the breakdown voltage means what? Like VBD increases with an increase in the level of doping on the N side. I think this statement is incorrect, because I think the breakdown voltage is inversely proportional to what? The level of doping on the lightly doped side. So the lightly doped side, the more lightly doped it is, higher and higher the breakdown voltage will be. Okay. We'll also do the math. So for breakdown, the peak electric field in the depletion layer should become equal to what? That minimum required electric field called as the critical electric field. Whatever be the type of breakdown, whether it is Zener breakdown or avalanche breakdown, the peak electric field strength in the depletion layer, which is denoted by EM. So for breakdown, BD means breakdown. So for breakdown, EM must become equal to what? E critical. Okay. Now what is that? EM, peak electric field strength in the depletion layer. Now how do you get the expression for the peak electric field strength in the depletion layer? Remember, the field profile has the shape of what? A triangle. So the field profile is what? Triangular. And the area of the triangle in the field profile is nothing but the net voltage across the depletion layer. So we have half into W depth times EM, which is the area of the triangle in the field profile, is equal to VDL, which is the net voltage across the depletion layer, which in reverse bias is what? VBI plus VR. Yes or no? This is VBI plus VR. So again, your applied reverse voltage, especially when the diode is going towards what? Breakdown, will be far greater than VBI, which is the built-in voltage drop. So VR will be far greater than VBI, and that VR is nothing but VBD. Yes, if EM becomes E critical, whatever VR you apply is what becomes the breakdown voltage VBD. So on the right hand side, it is okay to write VBD because VR is far greater than VBI, and the value of VR at which this happens is nothing but VBD. So from here, your EM can be written as 2 VBD by what? W depth. 2 VBD by W depth. Now again, you know the expression for W depth. Okay. Anyway, we'll come back to this equation. So in place of EM, let me write 2VBD divided by W depth. And this is equal to what? The critical electric field. So you can say VBD can be written as E critical divided by 2 times W depth. Now I'll write the expression for W depth. You know, W depth is given by this expression, where W depth is inversely related to what? The effective doping density. Again, for P plus N, it is what? ND, N effective. So square root of 2 epsilon SI times VDL. VDL, I'll just write it as VBD divided by Q times N effective. P plus N junction, N effective is what? ND. Now what? Let's square it on both the sides, because I am trying to get an expression for the breakdown voltage VBD. I'll try squaring it on both the sides. When I do that, I'll get VBD square is equal to E critical squared divided by 4 times 2 epsilon SI VBD divided by QND. So 1 VBD and 1 VBD on either side will get cancelled out. So finally you'll get VBD is equal to E critical squared divided by 2 times epsilon SI by QND. Okay. So I'll just pick a different color and write the final expression for the breakdown voltage VBD, which is going to be E critical squared times epsilon SI divided by 2QND. So as you can see, the breakdown voltage is inversely proportional to what? The level of doping on the N side. And what is the statement telling? The breakdown voltage increases with an increase in the level of doping, which is incorrect. Okay, so from this expression for VBD, we can see that as ND increases, VBD will decrease. But the statement is telling otherwise. So C statement or C option is what? Incorrect. So earlier two options were correct, C is incorrect. Let's move on to the D statement. Again, in a P plus N junction, same P plus N junction, under forward bias, fine. The diffusion capacitance is what? CD decreases with an increase in the level of doping on the N side. Okay. So the option implies that when ND increases, okay, increase in the level of doping on the N side, that means as ND increases, they are saying the diffusion capacitance value will decrease. Okay, so let's find out if this is correct or not. So first of all, what is this diffusion capacitance due to? Diffusion capacitance is due to what? The storage of the excess minority carriers in the neutral regions. Yes, so in forward bias you have what is called injection of minority carriers, which will diffuse in the neutral regions, and that will lead to what? This diffusion capacitance. Okay, and for junction capacitance, I told you what? You have to remember the parallel plate capacitor. But when it comes to diffusion capacitance, you should remember what? The time constant. Okay, so what is a time constant thing? RC is equal to what? Tau. Now in the context of diffusion capacitance, R, capital R is what? The small signal resistance of the diode, which is small r sub small d, and C is what? The diffusion capacitance, and tau is what? The lifetime of minority carriers. Again, in a P plus N junction, as I already told you, the current is primarily due to what? Injection of holes from P side to N side. So on the N side, whatever holes get injected from P side, there will be what excess minority carriers whose lifetime is what tau p. So this time constant tau is nothing but tau p, okay? And you know from analog circuits, the small signal resistance of the diode is what? The thermal voltage Vt divided by whatever is the DC current that is flowing through the diode, which is also called the on current. So Vt divided by I on, or you can directly write ID, yes, times CD is equal to tau p. So the point to note is what? The diffusion capacitance. I mean Vt by ion will go to the other side. So the diffusion capacitance is proportional to what? Ion. So CD, it is proportional to what? Ion. And ion is nothing but the diode current. Ion is nothing but the diode current. P plus N junction, the diode current is almost equal to what? The whole injection current, which is IP. In fact, the very first option we understood that IP is inversely proportional to what? The level of doping on the N side, that is ND. So this is inversely proportional to what? ND. So now we can decide whether the given statement is correct or incorrect. So clearly CD and ND are inversely related to each other. So if ND increases, definitely CD will decrease. So option D is also correct. So this statement is indeed a correct statement, okay? So I think out of the 4 statements, except option C, the other 3 options are correct. So what is the correct answer that you should be marking? A, B and D. A, B and D. Only option C is what? Incorrect. Let me just verify. Yeah. Fine. Let's move on to the next question. An N-type semiconductor is subjected to uniform illumination with an optical generation rate of 10 to the 18 per centimeter cube per second. So what is a 10 to the 18 value? It is the value of GL, okay? So if you want, I can just write it here. So this is GL. If the minority carrier lifetime, N-type semiconductor, what are the minority carriers? Holes. If the minority carrier lifetime is 2 microseconds, what is this 2 microseconds? Tau p. Then at steady state, the increase in conductivity means what? Delta sigma is dash into 10 to the minus 4 ohm inverse centimeter inverse. Assume low level injection condition exists. The values of mu n and mu p are given. Fine. Say under low level injection conditions, what is the value of the excess carrier concentration at steady state? First of all, due to light, excess carriers are created in pairs. So del N and del P both will be equal. And under the so-called low-level injection condition, the excess carrier concentration at steady state is what? GL times tau p. Just substitute the values into this expression. 10 to the 18 times tau p, which is 2 micro, that is 2 into 10 to the minus 6. So it is what? 2 into 10 to the 12 per centimeter cube. Here is the value of del N and also the value of del P. Now they are asking what? The steady state increase in conductivity, not the actual conductivity itself, but the change in conductivity. So delta sigma is equal to what? Q times, Q times mu n plus mu p times, you can write either del n or del p because both values are equal. I'll just write del p. That's all. So what is Q? 1.6 into 10 to the minus 19. mu n is 1350 and mu p is what, 650. So what is mu n plus mu p? It is 2000. And del p is what, GL tau p, which is 2 into 10 to the 12. Okay. So what is 1.6 into 2? It is 3.2. 3.2 into 2000. 3.2 into 2 is what? 6.4. So 6.4 thousand, I'll write it as 10 power 3. And then 10 to the minus 19 times 10 to the 12 is what? 10 to the minus 7. But your answer has to be what? What times 10 to the minus 4? I think 10 power 3 into 10 power minus 7 is what? Exactly 10 to the minus 4. So the increase in conductivity is what? 6.4 into 10 to the minus 4. Again, units, ohm inverse, centimeter inverse. So what is the answer that you should enter? 6.4. So what is the exact answer? It is 6.4. Let's move on to the next question. I'll just read it first. A P plus N junction, there is a P plus N junction across which a forward bias voltage of 0.6. So this 0.6 is what VF is applied, and the PN junction has the following parameters. On the N side of the junction, why N side? Because that is the lightly doped side, okay? And it is the lightly doped side which will control most of the parameters of a P plus N junction, okay? So on the lightly doped side, that is on the N side, ND is what given, fine. dP, diffusion coefficient or constant for holes, is also given. Even the lifetime of holes is given. Everything is on the N side. Assume Ni is this much and Vt is what, not 26 but 25 millivolts. Even the value of e to the 24 is given, 2.65 into 10 to the 10. The question is what to find? Diffusion capacitance per unit junction area. What is it? Diffusion capacitance per unit junction area is dash microfarad per centimeter square. Already I told you diffusion capacitance means what? You should remember the time constant thing. RC is equal to what? The time constant. Where that R is what? The small signal resistance RD, and C is what? The diffusion capacitance CD, which is what we need to find. And this product is what? The lifetime of holes on the N side, which is tau P. So tau P value is already given. And also RD is what? Vt by ID times CD is equal to what? Tau P. So from this, what is CD? It is ID times tau P. Yes or no? ID times tau P divided by Vt. ID times tau P divided by Vt. In fact, this ID times tau P is nothing but Qp. What is that Qp? Total charge stored on the stored in the neutral region of the N side in the form of the injected minority carriers, which are what? The excess holes. So this ID is what? Current. Tau P is what? Some kind of time. Current is what? Charge by time. Charge by time into time is what? Some charge. So this is actually what? Qp. I mean, these things we have done in class, but still. So CD is what? Qp by Vt. Where that Qp is, as I said, the charge due to the excess holes that are stored in the neutral N region. In fact, what is the total number of excess holes stored in the neutral N region? It is Pne minus Pn naught into A into Lp. That is the total number of excess holes stored in the neutral N region. Yes or no? I repeat, Pne minus Pn naught times A into Lp. And then what is the charge of each hole? Small q. Yes. So if you multiply the total number of excess holes with the charge of each hole, then you'll get the total positive charge that is stored in the neutral N region, which is nothing but QP. Okay. So QP divided by VT. So that QP is what? PNE minus PN naught times A times LP divided by VT. Okay. Now in the equation they are asking the diffusion capacitance per unit junction area. Just bring A from the right hand side onto the left hand side. It will go and divide this CD. You get CD by A. The CD by A is nothing but diffusion capacitance per unit junction area, which is given by this expression PNE minus PN naught times LP divided by VT. What is this PNE? It is the whole concentration at the edge of the depletion layer on the N side. And you know from junction law, PNE is given by PN naught e power VF by VT. So PN naught comes out. So you can also write this as PN naught times e power VF by VT minus 1 times LP divided by VT. So we just need to evaluate the value of this expression. That would be the answer. Okay. So we'll continue here. So CD by A is what? PN naught e to the VF by VT minus 1 times LP divided by VT. LP divided by VT. And remember, LP is what? The diffusion length of holes in the neutral N region, which is equal to what? Square root dP tau P. Yes or no? Yes. So what is Pn naught? Ni square by Nd. Ni, you have to take it as 10 to the 10. So Ni square will be what? 10 power 20 divided by Nd, which is 10 power 14. 10 power 20 by 10 power 14, directly I'll write 10 power 6. So Pn naught is what? Sorry. Pn naught is what? Ni square by Nd, whose value is 10 to the 6 times e power Vf by Vt. What is Vf? 0.6. Vt is what? 25 millivolts. 0.6 volts is what? 600 millivolts. Thermal voltage, which is 25 millivolts. So this millivolts and millivolts will get cancelled. 600 by 25 is what? 24. That is why in the equation e to the 24 value is given. So e power 24 minus 1. In fact, this 1 can be neglected in comparison to what? E to the 24. So the value of this factor, directly you could write it as what? 2.65 into 10 to the 10. Okay. I'll just do it. So e to the 24 is what? 2.65 into 10 to the 10. Now your LP, what is LP? You know it is square root dP tau P, which is square root, what is dP? 100 by 2.65 squared times tau P. Tau P is what? 1 microsecond, which is 10 power minus 6. What is 100 into 10 to the minus 6? 10 power minus 4. And then square root of 10 power minus 4 is what? 10 power minus 2. So the value of LP will be what? 10 to the minus 2 divided by 2.65. So in place of LP, I'll write 10 power minus 2 divided by 2.65 divided by the thermal voltage, which is Vt, 25 millivolts, or you can write it as 25 into 10 to the minus 3. Now I think a few things will get cancelled out. Let's see. First of all, this 2.65 and this 2.65 will get cancelled out. 10 to the 10, 10 to the 6 is what? 10 power 16. 10 power 16. Did I miss something? Shit. I actually forgot to write Q here. I'm sorry. This QP is what? This PNA minus PN0 into A into LP is only what? The total number of excess holes. So here there is also Q. Here also there is Q. Here also there is Q. Even here there is Q. So what is this Q? Electronic charge, which is 1.6 into 10 to the minus 19. 10 power 10, 10 power 6, 10 power 16 by 10 power minus is what? 10 power 19. That 10 power 19 and this 10 power minus 19 will get cancelled out. Okay. So this 10 power 6, 10 power 10, 10 power minus 3 and this 10 power minus 19 will get cancelled out. Then what is left? I think 1.6 by 25 and then 10 to the minus 2. Okay. So I'll just find out. 1.6 divided by 25. 0.064. 1.6 by 25 is what? 0.064 into 10 power minus 2. What will the units be? Farads per centimeter square. But our answer has to be in the units of microfarad per centimeter square. Microfarad means what? 10 to the something times 10 power minus 6 farads per centimeter square. So this 0.064, if you multiply it with 10 power 4, if you multiply it with 10 power 4, I think you'll get 640. Okay, 640 into 10 power minus 6 farads per centimeter square. So this 10 power minus 6 farads per centimeter square is nothing but microfarads per centimeter square. So the answer is what? 640. So what is the answer? It is 640. Okay, you just have to be careful with the calculation. So the answer is what? 640. That is the diffusion capacitance per unit area at an applied forward voltage of 0.6 volts. Okay. I think again we have an MSQ. You have to identify the correct statements among the 4 statements A, B, C and D. Once again, let's look at the statements one by one. What is the first statement? Resistivity, meaning what? Rho of an intrinsic semiconductor. Intrinsic semiconductor means what? N and P both are equal to Ni, decreases with temperature. So when temperature increases, they are saying rho will decrease. Let's find out whether this is correct or not. First we'll write the expression for conductivity. Sigma I, you know, is what? The conductivity of an intrinsic semiconductor, and sigma I is what? Q Ni times mu n plus mu p. Okay, and you know how Ni depends on temperature and band gap. Ni is proportional to what? T to the 3 by 2 times exponential minus Eg by 2 kT. Yes. So Ni is proportional to what? This thing. Whatever I just said. And in an intrinsic semiconductor, the only scattering mechanism that you have is what? Lattice scattering. And always the mobility due to lattice scattering will be proportional to what? T power minus 3 by 2. Temperature increases, mobility will decrease due to what? Lattice scattering. Okay. So mu n plus mu p is proportional to what? T power minus 3 by 2. This Q anyway is what? Constant, 1.6 into 10 to the minus 19. Now when you multiply Ni and this mobility factor, this T power 3 by 2 and T power minus 3 by 2 will get cancelled. You will get sigma I is proportional to what? Exponential minus Eg by 2 kT. Now you know resistivity is what? Inverse of conductivity. If sigma I is proportional to this, then rho I, which is nothing but 1 by sigma I, will it not be proportional to exponential Eg by 2 kT? Yes or no? E power Eg by 2 kT. Now when temperature increases, the value of the exponent, what is the exponent? E power whatever you have, that is the exponent. Okay, Eg by 2 kT will decrease. Then the exponential will also decrease. Then rho I will also decrease. Okay. Sorry. Rho I will decrease. Rho I decreases, it means what? Conductivity will increase. I mean, it is true. For an intrinsic semiconductor, as temperature increases, conductivity also will increase because you will have more and more thermally generated EHPs as temperature increases. More carriers would result in higher conductivity and lower resistivity. Okay, but same is not true for extrinsic semiconductors. Okay, but this option is what related to intrinsic. So temperature increasing, resistivity decreasing. Option A is correct. Moving on to the second option, conductivity. Okay, this is extrinsic. Conductivity of an extrinsic semiconductor at room temperature increases with temperature. Okay, fine. I mean that extrinsic semiconductor, it can be either N-type or P-type. Let us say it is N-type. You can also consider the extrinsic semiconductor to be P-type, but let's say it is what? N-type. Now, what is conductivity of an N-type semiconductor? Q, N, mu N. And N is what? Nd. So, Q, Nd times mu N. So, as long as the semiconductor is what? Intrinsic, N will be equal to what? Nd, and Nd is what? The donor doping density, which is constant. Or to be even more precise, you should write N as what? Nd minus Na. Yes or no? For an N-type semiconductor, N is what? Nd minus Na. Okay. If you want, I can do that. So Q times Nd minus Na times mu N. So as long as the material or the semiconductor is what? Extrinsic, that Nd minus Na is what? Constant. So N is also constant. So this factor, it is what? Constant. So it is only this mobility that will vary with temperature. At room temperature, what is the dominant scattering mechanism? At room temperature, usually even for extrinsic semiconductors, the dominant scattering mechanism will be what? Lattice scattering. Okay. And you know, due to lattice scattering, the mobility will reduce with increasing temperature. So sigma is proportional to mu n, which in turn is proportional to our T power minus 3 by 2. So clearly, as temperature increases, mobility will decrease, conductivity also will decrease. For intrinsic semiconductor, as temperature increases, conductivity increases. But for extrinsic semiconductor, yes, as temperature increases, conductivity reduces. What is the statement? Conductivity of an extrinsic semiconductor at room temp increases with temperature, which is incorrect. It reduces with temperature. Look at the C statement. Non-uniform doping will always lead to what? A built-in voltage drop. True. Yes, that is always true. So whenever you have non-uniform doping, that will immediately lead to what? Diffusion of carriers. Yes. And at thermal equilibrium, there should not be any net flow of carriers of any type. No net movement of or no net flow of free electrons, and also no net flow of holes. Okay. So due to non-uniform doping, definitely the holes will diffuse or the electrons will diffuse. So let us say holes are diffusing. Yes. And then it reaches what? Thermal equilibrium. This device or the semiconductor which is non-uniformly doped will ultimately reach what? Thermal equilibrium, where there will be no net flow of holes. But due to non-uniform doping, there will be what? Diffusion of holes. So there has to be something that will cancel out this diffusion of holes, and that thing is what? Drift of holes. And how do you get drift? By having what? Electric field. But at thermal equilibrium, you don't apply any voltage from outside. So within the device, a dipole will be formed which will create what? A built-in electric field, and that built-in electric field will result in a drift current which will cancel out this existing diffusion current. Therefore, the net hole current density in this case will become what? Zero. So always non-uniform doping will first result in what? Diffusion, which will be cancelled out by having what? A built-in voltage drop and also a built-in electric field. Okay, and that is what this statement also is telling. Non-uniform doping will always lead to what? A built-in voltage drop, which is correct. In a semiconductor at thermal equilibrium, the net drift current is zero. In a semiconductor at thermal equilibrium, net drift current is zero. Is it true or false? It is false. Okay. So in a device or a semiconductor at thermal equilibrium, what current is zero? Net hole current is zero. Yes. Jn is what? Net electron current density, that is zero. Jp is what? Net hole current density, that is also zero. So if you take any one type of carrier, for example, if you take electrons, electron drift and electron diffusion, the algebraic sum will be what? Zero. Yes. Or if you take hole drift and hole diffusion, the algebraic sum is what? Zero. Yes. No, total drift current is not zero. Similarly, total diffusion current is not zero. Net current for any carrier will be what? Zero. But this is saying net or the total drift current is zero, which is incorrect. In fact, if you take a PN junction, which is at thermal equilibrium, means what? No light is incident on the junction, and also no external voltage source is connected across the junction. In such a case, the PN junction is said to be at thermal equilibrium. So on the N side, some positive ions will be there, and on the P side, an equal number of negative ions will be there, and there is going to be this built-in electric field, that is EBI. Okay, so due to EBI, which is what? The electric field or the built-in electric field, there is going to be what? A drift current. Okay, so what is the direction of hole drift current? In the same, any drift current, whether it is electron drift or hole drift, the drift current will always be in the direction of electric field. So what is Jn drift direction? Like this. What is Jp drift direction? Also like this. Now if I ask what is the total or the net drift current, you should add these two drift current components, because both are in same direction, they won't get cancelled. When you add these two drift current components, Jn drift and Jp drift, the sum will not be zero. The sum will be what? In the same direction. Okay, so this is J drift, which is like the net drift current. the net drift current density, which clearly is not 0. Okay, in fact, because the current is flowing towards the left, the value of the current will be what, some negative value. The point is what, this value is not 0, but the statement is saying the net drift current is 0, which is incorrect. I think, okay, D is incorrect, C is correct, B is incorrect, A is correct. I think statements A and C are correct. Okay. A, C are correct, B and D are incorrect. Okay. Moving on to the next question. A voltage of 3 volts is applied across a mass cap. That means this 3 volts is what, the value of VGB. The flat band voltage of the mass cap is minus 1 volts. So minus 1 is what, VFB. And the thickness of the oxide layer is 6 nanometers. So this is Tox. If the resulting surface potential means what? Psi S is measured as 1 volt. So what is this 1 volt? It is Psi S. Then the electric field in the oxide layer is dash kilovolts per centimeter. What is the universal relation between the applied voltage, the flat band voltage, and the drop across the oxide layer and the drop across the substrate? VGB minus VFB is equal to what? Psi S plus Psi Ox. So except Psi Ox, all remaining values are given in the question. So in place of VGB you write 3. VFB is minus 1. So 3 minus 1. Even the surface potential Psi S is 1. And then you have Psi Ox. So 3 plus 1, 1 cancel out. So Psi Ox, the drop across the oxide layer is what? 3 volts. But the question is to find what? The electric field in the oxide layer. So E ox, electric field in the oxide layer, is simply equal to what? The drop across the oxide layer divided by the thickness of the oxide layer. That is Psi Ox by T ox. So what is Psi Ox? We got it as 3 volts divided by T ox, which is 6 nanometers. Nanometers, 1 nanometer is how many centimeters? 10 to the minus 7 centimeters. So 3 by 6 is what? 0.5. 1 by 10 power minus 7 is what? 10 power 7. So you can write this as 5000 into 10 power 3 volts per centimeters. So this 10 power 3 volts per centimeter is nothing but kilovolts per centimeter. So what is the answer? It is 5000. So the answer that you should enter is what? 5000. Okay. That is the electric field in the oxide layer. Moving on to the next question. So a MOSFET circuit is given. There are 2 transistors, M1, M2, both are NMOS. What is given about the 2 transistors? That both are identical and have a threshold voltage of 1 volt each. So the value of VTH of each transistor is what? 1 volt. The value of VDS, voltage between drain and source, of M2. This is M2, the upper transistor M2, for which you need to find the value of VDS. Okay, so both are identical, fine. I think for M2, we already know the gate voltage as well as the drain voltage. If you know gate and drain voltages, you can always check the condition for active, not active, saturation or triode. For BJT, you have active and saturation. For MOSFET, you have what? Triode and saturation. So for M2 to be in saturation, NMOS to be in saturation, drain must be more than gate minus threshold. For M2, drain is what? 5. Gate is what? 4. threshold is what? 1. 5 greater than 3. It is correct. So M2 is in saturation. So transistor M2, straight away we can say M2 is operating in saturation. What about M1? Now for M1 you have two options, either triode or saturation. If M1 also operates in saturation, remember the two transistors are connected in series. So no matter what the individual region of operation is, the two transistors should carry what? The same current. I2 and I1 both must be equal. Okay? And also it is given that both are identical. Identical, it means what? Both have same strength. That mu Cox W by L factor, it is same for both. If M1 operates in saturation, and we already know M2 is operating in saturation, then are we not having two identical transistors carrying same current, because both are in series, operating in saturation? If M1 operates in saturation, we have two identical transistors carrying same current operating in saturation. In such a case, the two transistors should have the same overdrive voltage, that is VGS minus VTH. Since VTH is also same for both, even VGS has to be same for both. Okay. So what is VGS of M1? If we assume M1 is in saturation, then VGS1 equal to VGS2. Already VGS1 is what? 4 minus 0, which is 4. So both VGSs must be equal. So if you write this drop between gate and source of M2 also as 4, this is 4, drop 4, then the voltage at this point would become what? 0. Now if you look at M1, drain is 0, source also 0. There is no drop between drain and source. Then the current will become what? 0. Then the current will actually become what? 0. But that is not possible, right? Because some current will flow through M2, because there is a drop between drain and source, 5 minus 0. Current flowing through M2, but current through M1 becomes 0. Then I1 and I2 are not really equal. So this does not make sense. What does not make sense? M1 in saturation makes no sense. So obviously M1 must be in triode. That's all. So the lower transistor is going to operate in triode, whereas the upper transistor will operate in saturation. Okay, M1 in triode, M2 in saturation. Now let's do the analysis and find the required value. What is the required value? To find VDS of M2. Fine. So here we have the same circuit. Current through M1 is what? I1. Current through M2 is what? I2. So what is this drop? It is VGS1, which is 4. What is this drop? Okay, I'll do one thing. Let me call the voltage at this node as what? Vx. And this drop is what? Like VGS2. Okay. And this drop is what? VDS1, which is Vx. So what is VGS2? It is 4 minus Vx. And what is VDS1? VDS1, it is Vx. Okay, now I am going to equate the two currents. I1 equal to I2. Remember, M1 is operating in triode. What is the drain current equation in triode? Mu n Cox W by L times VGS minus VTH of M1. 4 minus threshold is what? 1. 4 minus 1 times VDS of M1, which is Vx, minus half VDS of M1 squared, which is Vx squared, is equal to I2, which is the drain current of M2, and M2 is in saturation. So the equation goes like this: half mu n Cox W by L, VGS2, that is VGS of M2, which is 4 minus Vx. Correct, right? Oh, I'm sorry. 4 minus Vx is what? Vgs2 minus Vth, that is minus 1 whole squared. Now what? Because both are identical, this mu and Cs Wbel and this mu and Cs Wbel both will get cancelled out. As always, you will get a quadratic equation. 4 minus 1 is what? 3. So 3 Vx minus half Vx squared, correct? Half Vx squared is equal to half into 3 minus Vx whole squared. So half into 9 plus Vx squared minus 6 Vx. I hope I did not make any mistake. Now I'll multiply both sides with 2. 2 times 3 is what? 6 Vx. 2 times half, 2 will get cancelled. Minus Vx squared. Even this side 2 will go away. 9 plus Vx squared minus 6 Vx. So what is the quadratic equation that we get? 2 Vx squared minus 12 Vx plus 9 is equal to 0. I hope this is correct. I will try to find the roots of this equation. 2 minus 12, 9. So my two roots are the following: 5.12 volts and then 0.88. These are my two values of Vx. Look at this Vx. Is it not in between 5 and 0? So the value of Vx has to be some value in between 5 and 0. The first root is outside that range between 0 and 5. It is 5.12, which is outside the range. So this cannot be the correct root or the correct value of Vx. But 0.88 is what? In between 0 and 5. It makes sense. So the value of Vx is what? 0.88 volts. Okay. So Vx is what? 0.88 volts. But the question is not to find Vx. What is the question? It is to find VDS of M2. VDS of M2 is what? Draw between drain and source of M2. Drain of M2 is what? 5. Drain of M2 is what? 5. Source of M2 is what? Vx. Okay. So VDS 2, which is VDS of M2, it is what? 5 minus Vx. 5 minus 0.88, which is 4.12 volts. So the answer that you should be, indicating in your response is what? 4.12, not this 0.88, because 0.88 is what? VDS of M1, whereas the question is to find VDS of M2. So what is the answer? 4.12. I hope it is clear. Alright, look at the next question. The VTC means what? Voltage transfer characteristic of an inverter is shown. VTC means what? Plot between V0 and Vi. There is V0 versus Vi plot. It is, piecewise linear, but the usual plot, it will be like this. Okay. Anyway, what is the equation? The value of NML is what? Noise margin on the low input side. Okay, and NMH is what? The noise margin on the high input side. So the values of, the sum of the two noise margin values, that is what you need to find. Now from this V0 versus Vi plot, which is the voltage transfer characteristic, you need to deduce the values of VOH, VOL, VIL and also VIH. So this 5 volts it is what VOH. 0.5 volts is obviously VOL. 1.8 volts will be what VIL, and 3 volts will be what VIH. Now what is the noise margin on the low input side? NML is what VIL minus VOL. 1.8 minus 0.5, which is 1.3 volts. And then what is the noise margin on the high side? It is VOH minus VIH. VOH is what 5, VIH is what 3, 2 volts. So when you add up the two noise margin values, 1.3 plus 2 is what 3.3. So what is the answer? It is 3.3. That is the value of NML plus NMH. Okay. Okay, I guess that's the end of EDC. So let me take this opportunity to take you through the various courses that we offer. This is our flagship course, which is the GATE offline course, and for GATE 2027, okay, the next year's GATE exam. The first batch starts on 26th Feb, that is after the GATE exam, okay. So if you really want to learn the subject as well as get a good rank and also become confident in the subject and develop a thinking ability, then this is the best option that is out there. Okay, nothing comes close to this. Anyway, you have to, inquire and find out how special OM is. Okay. Also, we have courses for GenCo, Transco, and Discoms. So I think in 2026, there are going to be a good number of notifications. Even next year, there might be some notifications. So for those aspirants targeting these state level PSUs, we have offline batches, and our next offline batch will be from 21st January, which is after this Pongal break. Okay. We also have a live course that is running for GenCo, Transco, Discoms. Almost 75-80% syllabus is covered. Okay, has been completed so far. We do have a record course for GTD as well. Okay, and this is our live course for GATE, again 27-28. This is mainly targeted for the college going students, especially students who are in second and third year, even in fourth year. So if you want to learn subjects in a more conceptual manner, okay, and also get a flavor of problem solving that is essential for GATE, a good entry point would be this online live course. And this year's first batch is starting from 2nd February. Okay, so live classes will be conducted throughout the year, and also you'll have access to the last year's recordings. Okay, every live session by default will be recorded. So even if you miss a live session, you can always go back and watch that session. Okay, so that's the live course for GATE. So we have both 1 year as well as 2 year programs. Okay. Alright guys, now let's look at the questions from analog circuits. So here we have the first question. For the transconductance amplifier shown below. So this block here, it is what a transconductance amplifier. So for this transconductance amplifier, the transconductance is given 20 millisiemens. Both the input and output resistance values are 20 kilo ohms. Find the magnitude of the overall voltage gain, that is V0 by Vs. So on the input side, this input voltage source Vs is connected, and for this input source there is also this internal resistance which is some 5 kilo ohm, and at the output a load resistance is connected whose value is what, 20k. You say, given the values of G, R in and R out, can't we draw an equivalent two-port network for this transconductance amplifier? You know, any amplifier can be modeled as a two-port network. So how do you do that? Any amplifier inside across the input port, you will have what, R in. So in this case, R in is what, 20k. Transconductance amplifier means what? Input is voltage and output is what? Current. Okay. So whatever voltage you will have across R in, that is nothing but the measured input voltage V in. And this input voltage will control what? The output current. So the output side or the output port of a transconductance amplifier can be modeled as what? A voltage controlled current source. Okay. So on the output side, we have this voltage control current source whose value is what? G times V in. What is it? G times V in. And then in parallel with this current source, there will be some internal resistance, and that is nothing but R out. Even the output resistance is also what? 20k. So this yellow color network you can draw in place of what? The transconductance amplifier. Now let us connect the external elements, whatever is connected across the input port and also what is connected at the output. Okay. So on the input side, what is connected? A voltage source Vs in series with a resistance which is 5 kilo ohms, and on the output side a load resistance is connected, and the value of this load resistance is also what? 20k, and whatever voltage you have across RL, that is going to be what? The output voltage. That's all. There is the complete circuit that can be drawn for the three given parameters of this transconductance amplifier. Okay. Now on the input side, we have a loop in which there are two resistors connected in series across what? A voltage source. Voltage division will take place. You can write Vn in terms of Vs, right? Vs times 20k upon 5k plus 20k. 20k by 25k is what? 4 by 5. So Vn is what? 4 by 5 Vs. Okay. Now this GVin current will get divided between what? R out and RL. Because R out and RL both are identical and equal to what? 20 kilo ohms each. This current will get equally divided between R out and RL. So what is the current through RL? It will be G Vn by 2. That's all, right? Now your output voltage V0 will be what? The current through RL multiplied with RL. So G Vn by 2 into RL. Substitute the values. G is what? 20 milli. 20 into 10 power minus 3 divided by 2, and Vn is what? 4 by 5 Vs. And then RL is what? 20 kilo, that is 20 into 10 power 3. I think this 10 power minus 3 and 10 power 3 will get cancelled. Vs will come to this side, then you'll have V0 by Vs. What is, so 2 into 5 is what? 10. 10 goes into 20 as what? 2. 2 into 4, 8. 8 into 2, 16. 16 into 10, 160. So my answer is what? 160. So the magnitude of the overall voltage gain, it is what? 160. Okay. I mean, it also can be minus 160 because this GV in current source direction, it need not always be in the upward direction. Had it been in the downward direction, then V0 by Vs would have been minus 160. Yes, but whatever be the direction of GV in, whether it is upwards or downwards, magnitude of the overall voltage gain does not change. Yes, it is always going to be what? 160. The actual gain can be what? Plus 160 or minus 160, but the gain magnitude V0 by Vs. Alright. In the current mirror circuit shown below, this is what the current mirror. Both the transistors are identical. Okay. So if this is Q1, this is Q2, both are identical. Fine. For a VBE, if the base emitter voltage drop is 0.7, the resulting collector current is what? 1 milliamp. So for VBE equal to 0.7, they are saying IC will be what? 1 milliamp. Assuming beta to be large, means what? The base current is 0 for both the transistors. For I0, this collector current to be 10 microamps. The required value of R, this resistance is how many kilo ohms? Take the value of Vt to be what? 26 millivolts. Okay. What is this current? It is 0 because the base current is 0 because it is given that beta is large. Even this base current is what? 0. If these two base currents are 0, then this current will be what? 0. Now Q1 and Q2, yes, they are identical. Not only they are identical, they are also connected in parallel. Identical transistors connected in parallel, operating in active, will have what? Same collector current. So if this current is I0, then this current is also what? I0. Now because this current is 0, even this current is also what? I0. And the value of I0 is how much? 10 microamps. Let us call this voltage drop as what? Some VBE. In fact, that VBE is also what? VBE of Q2. You should not write VBE equal to what? 0.7. No. VBE equal to 0.7 only when the collector current is what? 1 milliamp. But here, the collector current is not 1 milliamp. It is 10 microamps, which is 100 times less than 1 milliamp. Correct or not? So the collector current is less than 1 milliamp. Even this VBE will be what? Some value less than 0.7. So if you find that value of VBE such that the collector current is what? 10 microamps, then you can easily find the value of R because this base is shorted to what? This collector. Okay. So what is that equation for the collector current? IC is equal to what? IS times e power VBE by VT. Okay. Now in the equation it is given that when the collector current is what? 1 milliamp, IS times e power when the collector current is 1 milliamp, the value of VBE is what? 0.7 volts divided by 26 millivolts. But right now, for the two transistors, the collector current is what? 10 microamps. IS does not change. It is a constant for a given transistor at a given temperature. So let us say the new value of VB is what? Some VB itself divided by VT, which is again 26 millivolts. Now if you divide the two equations, 1 milliamp by 10 microamps is what? 100. Yes, 1 milliamp by 10 microamps is what? 100. IS will get cancelled. We want to get e power 0.7 minus VBE by VT, which is 26 millivolts. Now what? You should take ln on both the sides. Then you will get 0.7 minus VBE by 26 millivolts is equal to ln of 100. Correct? Alright, ln of 100 is 4.605. Okay, and that should be multiplied with 26 millivolts is what? 0.026. Correct? and that should be subtracted from 0.7, minus 0.7. So for the collector current to be what, 10 microamps, the value of VBE must be 0.58 volts. So what is the value of VBE? 0.58 volts, okay? That's all. If this drop is what, 0.58, start from this point. What is the voltage here? 0. Go from minus to plus, add the drop. So what is the voltage at the base? 0.58. Now because base is shorted to collector, what is the voltage at the collector? Also 0.58 volts. Now what is the drop across this R? 10 minus 0.58, which is 9.42. Okay. So R resistance is what? Voltage drop divided by current. What is the drop across R? 9.42 volts divided by the current through R, which is I0, which is 10 microamps. 10 microamps. 10 micro is what? 10 power minus 5. 9.42 by 10 power minus 5 is what? 942 kilo ohms. So what is the answer? It is 942 kilo ohms. It is purely based on the application of this relation between IC and VBE. IC is equal to what? IS times E power VBE by VT. Okay. Fine. I guess there is the last question. Let's just solve it. In the circuit shown above, in this diode circuit, initial value of VI, the input voltage is what? 0. So initially VI is what? 0. Fine. And then it is gradually increased. So starting from 0, VI is gradually being increased. Okay, 0.1, 0.2, 0.3, 0.4 like that. The value of VI at which diode D2 turns on is dash volts. The value of VI at which diode D2 turns on is dash volts. V on of the diode is what? 1 volt. V on of the diode is what? 1 volt. Okay. You see, V on 1 volt, it means what? For the diode to be on, the voltage across the diode should be greater than 1. Okay. What is the requirement at this point for D1 to be on? It should be greater than 10 volts for D1 to be on. What is the requirement at the same point for D2 to be on? Again, D2 N side is connected to what? 25. So P side must be what? Greater than 26. Greater than 26 volts for D2 to be on. So initially when Vi is 0, in fact, when Vi is 0, it is not more than 10, it is also not more than 26. So initially, when Vi starts at 0, both are off. Both are off. And then when both are off, no current flows in the circuit, then the drop across R would be 0. Then this Vi will directly appear at this point. And as Vi keeps on increasing, at some point Vi becomes greater than 10. In fact, when Vi exceeds 10 volts, D1 turns on. But D2 will continue to be off. Okay. So when Vi exceeds 10 volts, D1 it turns on, but D2 it is going to remain off. Okay. When D1 turns on, D1 will start behaving like a voltage source of value V on. So across D1 we'll have a drop of V on, that is 1 volt. Start from ground. This is ground. Go from minus to plus. Again you go. So what is the voltage at this point? It is 10 volts. So right now no current will flow in this branch because only D1 is on. So how will current flow right now? Like this and also like this. So can't you tell or can't you write what is the voltage at this point in terms of Vi and 10? Vi into R plus 10 into R upon R plus R. Correct, right? Which will be Vi plus 10 divided by 2. Okay, Vi plus 10 divided by 2. Now we want D2 to turn on. For D2 to turn on, already you know the voltage at this point must exceed 26. So just make the voltage at this point greater than 26. So what is 26 times 2? 52. 52 minus 10 is what? 42. So when Vi exceeds 42 volts, when Vi exceeds 42 volts, the voltage at this point will exceed 26 volts, and that is when D2 turns on. In fact, the question is what? To find value of Vi at which D2 turns on. So the answer is what? 42. So when Vi exceeds 42 volts, that is when D2 will turn on. When does D1 turn on? When Vi exceeds 10 volts. Okay. And after that, as Vi keeps on increasing beyond 42, both the diodes are going to be on. Okay. So some current will flow through D1, some current will also flow through D2, and those two currents will come from this direction. Okay. So anyway, the answer is what? 42. So these are the questions from analog circuits.
So let me discuss the questions I have given in the mock test network analysis. So total we have 7 questions, all the questions from different topics. I'll be dealing with all the questions and the suitable answers, and if there is any concept in that also we'll be discussing. So let's start. So the questions were made relatively, I made it easy or medium level, such that I don't want to make unnecessary toughness. I just want to make it in the level of gate exam. So let's move. So this is the first question from two-port networks. So the question here is, what is the value of Z11 and Z12? So what is Z11? We know that Z11 is nothing but V1 upon I1 at I2 equal to 0. So if you take I2, right, this is a 1 mark question. This is my V2, this is V1 and my I1. So what is V1 by I1? If you measure from this side, Z11 will be, all of them are in series because this current is 0 and parallel with 1. So 1 parallel with 5, 5 by 6. This is equal to Z22. Why sir? Because it is symmetrical. Otherwise you can make I1 0 and find V2 by I2. So both are 5 by 6 and 5 by 6. So it's a simple question from two-port networks. Next question. So this is a question from basics. So I have a non-linear resistance RNL. So generally the resistor is linear, but here it is non-linear. And the voltage current relationship is given by VNL equal to, just a moment. So the voltage relation is given by VNL is equal to INL square. So normally V equal to IR. Here Ohm's law is not applicable. R is not constant. Don't take the linear rules, but you can apply any KCL, KVL to any network, whether it is linear or non-linear. So we can solve the question by KCL for sure. So I have a 3-volt source and 2 ohms resistance. The power consumed by the RNL. So let me connect this RNL. As I told, don't apply Ohm's law, you can apply KVL. R is always V by I, but that R is not constant if it is not satisfying Ohm's law. So take the loop equation here by using KVL. 3 minus 2INL minus VINL equal to 0. So 3 minus 2INL minus INL square equal to 0. So let me solve this quadratic equation. Just a moment. I will get INL. So another two possibilities are coming. I am taking positive only. Negative is -3 is also possible, but assuming the resistor as passive, unless until it is specified, we assume it as passive. So we can take this as positive only, because we got -3 also. Rule it out, because if it is delivering, then you will get -3. Just a moment. Okay, sorry, something wrong with my system. Okay, so your power PNL equal to VNL into INL. So INL square into INL. That is INL into INL cube. That will give you 1. So that is about your basic question from network analysis. One more question. So when the current source of 1 ampere, suddenly connected, means it is connected at time t equal to 0 across a two terminal initially relaxed RC network. This is R and a capacitor at time t equal to 0. Just assume this is the circuit for t greater than equal to 0. It is observed that nature of the voltage across the current is ramp. For example, this is 1 ampere, this is 1 ampere. What is the drop you will get here? This is based on transients. So 1 into R you will get, plus current is 1 ampere. What is the voltage across the capacitor? 1 by C integration of initially no energy 0 to t current 1 dt. So this will give you a ramp signal. So my total voltage will be here, some constant plus T by C. But he said only ramp. So this must be 0. So it should be a pure capacitor. It should be a pure capacitor. So the next question also from the basics. In the circuit shown in the below, what is the value of R? Okay, examiner has given the information, the voltage here is 5 across the 1 ohm resistor. So I can find this current as 5 amperes. And because if it is 5, this should be how much? 10 volts. So this current will be 10 by 3. So what about this current? 10 by 5 minus 10 by 3. Calculate. 5 minus 10 by 3. 1.67. 1.666, but 1.67 you can take. So this will be 1.67 R, and this will be 1.67. Okay. So now multiply that with 3.5. So here what is the drop you will get? 5.83. So by the loop equation, I'm not writing the loop equation. I hope you know the KVL. 1.67 R equal to 10 minus 5.83. So your R comes out to be 2 point. Just take it other side and do the math. R will be 2.5 ohms. Let's move for the next. So the last three questions, these are the two markers. I have a capacitor connected in parallel with a series combination of resistor and inductor. So I have a capacitor connected with a series combination of R and L. Okay, so its net admittance will be real. When will you get real? Means he is asking resonance. Net resistance is real, net admittance is real, all unity power factor, all these conditions are considering it as a resonant condition. So there is a standard network which I hope you know, which we generally discuss in our regular class also. Right. So this is root of, what is the resonant frequency of this standard network is RL square minus L by C by RC square minus L by C into 1 by root LC. This is the standard resonant frequency for this network. So suppose here what is a given condition is just substitute RC equal to 0. I can find it by finding its admittance, make imaginary part equal to 0. I can definitely derive the resonant frequency. But exam point of view, this formula, if you remember for this circuit, you can find when RC 0, RL 0, RLRC equal all the conditions, you will be able to do this. So RC equal to 0, then what is your resonant frequency? 1 by root LC root of, if you make RC equal to 0, denominator minus LC minus L by C, you can take common 1 minus RL square C by L. Now take this LC to the inside. So root of 1 by LC. Here C cancels. R square or RL square, whatever may be, because RL is the resistance of the this one. R square. Here if you take LC to the inside, C cancels by L square. I mean, if you take the root total, so LC will go here, R square by L square. LC, L into L is L square, C cancels. Okay, so this one. Next one. Have I initially relaxed? This is the question from again. This is the AC analysis resonance circuit. I have covered all the 5 chapters, so you can understand. And this one is from resonance again, sorry, transients again. You have an initially relaxed RC series network. So initially there is no energy. We have applied the source at time t equal to 0, R equal to 2 mega ohm, and capacitor is 1 microfarad. One more question is there. I will finish it off. And I have applied a step voltage. Step itself initially means initially no energy. I have applied step means we applied at time t equal to 0, 10 u of t for t greater than equal to 0. Okay, so no initial voltage. So what is your formula for Vc of t? Sir, Vc of infinity into, because initially relaxed, 1 minus e power minus t by tau. This is the formula. Here tau equal to Rc 2 into 1 mega micro cancels 2 seconds. And what is Vc of infinity? If you assume steady state, by replacing the switch short circuit, capacitor acts as open and you get 10. So my Vc of t will be 10 into 1 minus e power minus t by 2. Now what is the examiner requirement is I need to find the response at time t equal to 2 after 2 seconds. So substitute t equal to 2. You get 10 into 1 minus e power minus 2 by 2. That will give you 6.8. 1 minus 0.3.68, that is 6.38. At one time, it will be 63.2% of your final value. That way also we can find the response. Thank you. Let's move for the next. So here I'm not explaining the concept. I hope you understand, not fully the theory and all directly, because it is the end of the examination. We are discussing just the solutions for your exam. So the last question here again from the two-port networks. So you can see they have given these things and I have given you the ABCD and I am asking you the parameters. So I mean the parameters are units, whatever may be. So what is your V1, I1, ABCD parameters? AV2 minus BI2. Last question, CV2 minus DI2. Okay. So firstly, what is A? When I2 equal to 0, I2 0 means output open circuit. Then what is your A? V1 by V2. Reverse voltage gain. What is this? Reverse voltage gain. And C equal to I1 by V2. It's like a transconductance. Okay. Transfer admittance because I by V. Now, what is 1 by C? 1 by C will be transfer. If you find input voltage, input current or output voltage, output current, we call it as a driving. Input voltage, input current ratio is a driving impedance or voltage by current is impedance, current by voltage is admittance. But if you are finding the ratio between output and input or input and output, they are called transfer impedances or transfer admittances. So 1 by C will give you transfer impedance. So 1 by C is a transfer open circuit transfer impedance, right? 1 by A is a open circuit voltage gain because this is V1, A is reverse voltage gain. So from this itself, maybe I am able to answer it. A must be 3 and C must be 2. A must be 3, C must be 2. A3, C is not 2 here. So I can directly say A is the answer to save the time in your exam. But if you want, I can give you the concept. Make V2 0, short circuit, then what is minus B is V1 by I2. This is again short circuit is common and transfer impedance, because voltage is at input, current is at output. Transfer impedance. So 1 by minus B will give you, transfer admittance. 1 by minus B, transfer admittance, short circuit. Lastly, what is your minus D from the equation? Minus D is I1 by I2. It will be reverse current gain, but 1 by minus D will give you the short circuit current gain. So short circuit current gain. All of them are satisfied. 1 is 3, 2 is 4, 3 is 2, and fourth one is 1. That's it. Option A. So those are the questions from my side for network analysis. So I hope you will be able to answer all the questions. These are just based on previous year gate, that particular level I made the questions, so that you will not be getting troubled, and it will also boost your confidence. And it can ultimate aim of the mock test is it should boost your confidence, and also it should point you some silly mistakes if you are able to commit, if you are possible to commit, that you need to do here, and in the final exam you should avoid them. So to learn from the mistakes. So we are starting 2027 new batches for offline in February 26th onwards for EC electrical engineering. You will be getting the offline from the best team. You will be getting for EC and electrical for sure. And Telangana and AP Genco Transco Discom batches are also going to start from 21st January for the offline. And yeah, we are starting this. I'm going to start network analysis on February 2nd on Ohm Live app, and you will be getting this Gate 2728 access for 1 year online course. So if you are not from Hyderabad, if you are from remote location or any other location, you want to access the top quality classes from the online platform point of view, I can say this is one of the best platform, no doubt in it, because we have the best faculty pool, quality educators for each and every single subject, not for one subject or two subjects. Every single subject are having this, we are having the specialized team for EC and electrical. I can assure you will get the best quality. So you can join this. You can avail 20% off also using the code OMGATE20. Or if you have any kind of queries, you can feel free to contact. So February 2nd onwards, if you want to start your journey for Gate 27, 28, the new batches are going to start. Thank you. All the best, guys.
Okay, so now let us move on towards the questions and control systems, a discussion of questions around control system. First one, MCQ 1 mark, simple block diagram based question. Okay, you can convert to graph as well. Let us see. CS is the Laplace transform of output, RS is the Laplace transform of input, equivalent transfer function, which is of course C by R. See, the first thing is, okay, you might think it is having multiple blocks, but no, it is. If you identify this, the half of the problem is solved. Why? Because these two are in cascade. So effective gain S square, then parallel with 1 by S. If you alone solve this one, it is going to be S square. Mass cascade means multiplied. Then add with 1 by S. So this is simply S square plus 1 by S, right? Parallel blocks, gains are added. And then only one operation. See, now you can convert to graph or not required here, because only one operation will finish the question. That's why I'm not going to graph. Shift this takeoff point. Okay, shift this takeoff point here. Okay, before a block to after a block, and whenever you shift a takeoff point before a block to after a block, okay, I'm doing takeoff point shifting. What happens? Okay, for your convenience, I will redraw this diagram. So I have the input R going to this summing point. Then there is this block whose gain is, okay, suppose for a moment, let me call this as G. Okay, for a moment, let me call this overall gain as G. Okay, then the output of this is entirely solved. There was a takeoff point which is removed now. Okay, the output of the G block goes to this integrator, gain 1 by S. Okay, and this is the final output C. Now already from C you have a takeoff point. Okay, with the feedback gain S. Okay, it enters to this summing point in the negative feedback, and then I'm asking you to shift this takeoff point here. But now if you shift the takeoff point, okay, earlier it was a unit gain branch. Will it still be unit gain? Of course, no. Whenever you shift a takeoff point before a block to after a block, gain of 1 upon g. 1 upon g means reciprocal with respect to the block, reciprocal of the gain of the block with respect to which shifting is done. So you have shifted with respect to 1 by s, and reciprocal of it is s. Okay, so in this takeoff path there will be a block of s. Okay, this is reciprocal of 1 by s. Okay, that is introduced. Now why I did this is, simple reason is, these two are again in parallel now. Okay, they have the same input and their outputs are added here. So s plus s, 2s. So you can call it as a net feedback gain 2s, and the net forward gain will be g is multiplied by 1 by s. Okay, g is multiplied by 1 by s. In that way, you're going to get your answer. Okay, so the final answer will be, final transfer function here is, okay, let it be, I've already solved it here. I will solve the answer directly. C by R, the forward path gain, g into 1 by s divided by 1 plus g into 1 by s whole multiplied by 2s, because the feedback gain s plus s, 2s in parallel. Okay, so writing down the value of g. Now g was s square plus 1 by s. S square plus 1 by s, further multiplied by 1 by s here, divided by 1 plus, now this s I'll directly cancelled. Okay, so 1 plus twice of g, and g is s square plus 1 by s. Okay, right. So to simplify the answer, the answer is how much? First I'll write down s plus 1 by s square upon 1 plus 2s square plus 2 by s, but multiplying by s square throughout, so answer should be s cube plus 1 multiplying by s square. Okay, then it should be 2s cube, this particular term. Okay, 2s power 4 rather. Okay, this will become 2s power 4 plus s square plus 2s plus 2s, correct? S cube plus 1 upon 2s power 4 plus s square plus 2s, correct? Answer is A. Yeah, the correct answer has to be A. Okay, done. Next question. Okay, simple MCQ 1 mark question. The root locus diagram of a control system is shown in the figure. Okay, one can get the following conclusion from the given plot. Okay, one can get the following conclusion from the given plot. What is that conclusion? The system is stable for small gain and unstable for large gain, or whether it is stable for large gain. Now you see here, root locus, okay, starts from open loop poles. Okay, and if this is open loop pole, the starting point you know is k0. Okay, the root locus starts from k equal to 0 and it starts from open loop poles. Okay, and it terminates on the open loop zeros or at infinity. Here open loop zeros are there, and terminating value k tends to infinity. Terminating value means k tending to infinity. That means when it is starting, it is in the left half plane. Both the branches are in LHP. Okay, up to this value of k, both the branches are in LHP. Okay, for which value of k? Okay, some value k1. Some value k1. That means for 0 less than k1, okay, the entire all root locus branches, there are two root locus branches. Okay, so all the root locus branches are in LHP. The system is stable. Okay, so system is stable for some small value of gain. Okay, because as k becomes greater than k1, okay, you will have RHP branches, and RHP branches means what? System, not all, even if one RHP branch, system is unstable. So when gain becomes above a certain point, the system will be unstable. Okay, so the system is stable for some smaller gain up to k1, and then after that it is unstable. So option number A, stable for small gain, unstable for large gain. Unstable for large gain, option number A. Okay, next question, easy one only. Next question, NAT 2 mark, state space analysis. What is the steady state error for unit step input of the following system represented by the state space form? The steady state error for unit step input. Okay, now see, transfer function can be easily obtained. How do you get the transfer function? Okay, the transfer function of the system can be obtained by the formula C phi B, where of course there is no D matrix. Okay, or generally C phi B plus D, where phi is given by SI minus a whole inverse. but this will lead to little bit calculation. Of course, it is generally required. Okay, Si minus A whole inverse, which is the Laplace transform of state transition matrix. C and B matrices are given. Okay, so Si minus A whole inverse, one calculation will be required. Or for this question, if you might have identified what type of form it is. Okay, the given model 0, 1 minus A naught, 0, 1 minus A naught minus A1 x plus 0 bu y equal to C naught C1 x. Okay, the given model is directly CCF, controllable canonical form. Okay, and if it is CCF model, okay, transfer function is given by b into C1s plus C naught divided by s square plus A1s plus A naught. Okay, b, the common term which is 1 here, into C1 is 0. Okay, only C naught is there. Okay, so only 1 will come up here. There is no s term. Denominator s square plus A1. Okay, that is plus 2s and then plus 4 plus A naught. Minus A naught is minus 4. Okay, right. Okay, so s square plus 2s plus 4. This is what it is, correct? S square plus 2s plus 4. Okay, so now if the transfer function is known to you, what is the steady state error? See, transfer function, okay, already obtained here. It's C by R, which is how much? 1 upon s square plus 2s for plus 4. 1 upon s square plus 2s plus 4. Okay, so what is going to be the output then? The output C will be the input, which is 1 by s. This is the input. Okay, because we need to find the error for unit step input, and unit step input means the Laplace transform is 1 by s. Okay, what is the steady state error? Okay, applying in S domain final value theorem, limit s tending to 0, s into Es. And what is Es? Rs minus Cs. So this becomes limit of s tending to 0, s into Rs. Rs is 1 by s. Cs also has this 1 by s into 1 upon s square plus 2s plus 4. Okay, so s and s will get cancelled. Okay, and then if you put tending to 0, 1 minus 1 upon 1 minus 1 by 4, these two terms are 0. So net answer is 3 by 4. Okay, 0.75 is what is the correct answer. Okay, right? Okay, 0.75, 3 by 4 is what is the correct answer. Okay, next question. Okay, right. MCQ 2 marks, very easy for 2 marks. Okay, very easy for 2 marks. A basic frequency response question. Okay, just the magnitude. It's more like a complex number question. The frequency response of a system is given by e power minus s tau d upon s at a frequency omega equal to pi by 2 tau d gives the magnitude and phase of how much? Okay, magnitude and phase of how much? See, it's a simple one. If you first convert it to the frequency domain, okay, because it's a frequency response question which is obtained by putting s equal to j omega in the transfer function, you get e power minus j omega tau divided by j omega. Okay, and when you want to separate into magnitude and phase, okay, what is the magnitude of this? Generally, the e power j theta magnitude is 1, j omega magnitude is omega. Okay, so at omega equal to what frequency? At omega equal to pi by 2 tau, the gain is reciprocal of this, that is 2 tau by pi. 2 tau by pi, this is obtained, and then the phase of this. Okay, angle gj omega will be how much? E power j theta, theta is the phase. What is theta? Minus omega tau. Okay, minus pure imaginary number 90 degree or pi by 2, writing down in the form of radians first, because e power j theta, theta is radian, that you have to be careful about. Okay, now putting down the omega value, what is the omega value given to me? Again, pi by 2 tau into tau minus pi by 2. So tau and tau here cancelled. Minus pi by 2 is minus pi. Okay, minus pi means minus 180 degree. Okay, so correct answer is how much? 2 tau by pi and minus 180. B answer. It has to be B answer. I told you, an easy one for 2 marks. Okay, but yeah, next one. The pole plot of a control system is given. Okay, what is the percentage overshoot? That too, final calculations not required. You just have to write down the answer in the form of exponential, because percentage overshoot is given by e power minus pi cot phi into 100. This is the simple way of writing the answer. Sorry. into 100 here, or otherwise you might have written the formula this way: e power minus pi into zeta upon under root 1 minus zeta square, anyways, into 100. Okay, now you see what is going to be the zeta here. The overshoot depends only on zeta. So if you look into this pole plot, the poles are complex conjugate in the LHP. The distance of the pole, okay, the distance of this complex conjugate pole with reference to the origin is omega n. Okay, the natural undamped frequency. Okay, and whatever is the angle subtended by the negative real axis is phi, and zeta is known as cosine of phi. Zeta is known as cosine of phi. So why to find zeta? Directly use the first form. Na? What is going to be cot phi here? What is the cot phi? Base upon hypotenuse. How much is the base and how much is the hypotenuse? Okay, this will be base divided by height. Sorry, I'm directly finding cot phi, na? Yeah. So directly I'll find the base by height. What is the base? Both of them are given. What is the base value is 1 here, and what is the height value is 2 here. 1 by 2. 1 by 2. Finish, na? So it is e power minus pi by 2 into 100. Okay, option number B. Option number B, right? All right. So control system slightly on a easier type, because many times in GATE you get control systems as easy and scoring only. So it was usually on, I would say, a very, very easier side. But okay, these were the 5 questions from the control systems.
Let's read this question. Let y is equal to minus 1 if x is less than 0 and plus 1 if x is greater than or equal to 0. So y is basically a discrete random variable which can take values minus 1 and plus 1. But it is clearly mapped to a continuous random variable. If you look at it, x is a continuous random variable with the probability density function given. For PDF of x given below, the value of fy of y, you will have to find out the probability density function of y. It's a clear model. Y is a discrete random variable, but it is mapped to a continuous random variable. That is probability that y is equal to minus 1 is equal to probability that x is less than 0, which is equivalent to, what is the probability that x is less than 0? If you look at it, this particular area, isn't it, which is base is half into height is 1 by 2, which is equivalent to 1 by 4. Now probability that y is equal to plus 1, there are two ways of doing it. You can also, since there are only two possible values, you can always do 1 minus 1 by 4, which is 3 by 4. Else probability that y is equal to plus 1 is equal to probability that, if you look this from here, probability that y is equal to plus 1 is same as probability that x is greater than or equal to 0, which is equivalent to x greater than 0 means this particular area half into the base into the height into the base is 3 by 2, which is 3 by 4. Now very clearly, the probability density function for a discrete random variable, this is a discrete random variable, will have a PDF probability density function in terms of impulses. So how do you mark this fy of y? Fy of y is equal to, when y is equal to minus 1, the probability is 1 by 4. So 1 by 5, 4 del of y plus 1, and the probability is 3 by 4 for y is equal to plus 1, that is del of y minus 1. This will be the corresponding final answer. If you look at it, it should be 3 by 4 del of y minus 1 plus 1 by 4 del of y plus 1. Answer should be C. Okay, this is the first question. Now if you look at the next question, the probability of a random variable x is given by f of x is equal to, the PDF is given, it's clearly a uniform random variable. Why? Because if you look at the width is 4, the height is 1 by 4, it's a uniform random variable. Probability that mod x is greater than 1, probability that mod x is greater than 1, probability that mod of x is greater than 1. Okay, so no, this should be probability that mod x is greater than 1. Okay, probability that mod x is greater than 1 is same as it has to be probability that mod of x is greater than 1. Probability that mod x is greater than 1 is same as probability that x is lying between -1 to +1. So now if you actually draw the probability density function, it will look like this. The probability density function will be -2 to +2. This is x, fx of x, -2 to +2, height is 1 by 4. Okay, so lying between -1 to +1 means it's somewhere here, -1 to +1. So what is the probability? The base is 2. The base is 2. If you look at it, in fact, even without drawing it, you could have done it directly from this particular equation itself, because the base is 2. -1 to +1 means base is 2. Height is 1 by 4, it's mentioned here. So this is 2 into 1 by 4, which is equal to half. Answer should be B. Okay. Now, an AM and a narrowband FM with identical carriers, modulating signal and modulation indexes are of 0.1 are added. The resultant signal can be closely approximated to. So you have an AM plus a narrowband FM. Is indirectly telling you the modulation indexes can be the same. Now NBFM, the very basic rule for NBFM is it's very similar to AM, except for a 180-degree phase shift for the LSB component. That is, AM, if you look at it, there is carrier plus upper sideband plus lower sideband. Here if you look at it, it's very similar to AM, except for a 180-degree phase shift for the lower sideband component. This is minus LSB. So if you add it up, the lower sideband components gets cancelled out. So effectively you will have a carrier along with a sideband. So that is what a carrier along with a sideband means. It is indirectly SSB, single sideband SSB, because single sideband clearly the upper sideband along with carrier. In which case SSB with carrier, answer should be B. Now let Z of t is equal to x of t plus y of t, where the random process x of t and y of t are jointly White's and stationary, and the means are 0. Then which of the following are correct regarding the power spectral density and autocorrelation? RZ of tau. Look, if you look at it, RZ of tau is same as expectation of Z of t1 into Z of t2, where tau is equal to t1 minus t2, since it's White's and stationary. If you look at it, this is can be written as expectation of x of t1, wherever there's a, because Z of t is equal to x of t plus y of t, x of t1 plus y of t1 into x of t2 plus y of t2. Now if you open this up, this is, in fact, this multiplication will give you 4 terms. The first 2 terms, when I multiply, expectation of x of t1 into x of t2 is same as rx of tau, isn't it? Now the same way around, x of t1 into y of t2, it is r xy of tau plus y of t1 into x of t2, isn't it? So r yx of tau plus y of t1 into y of t2, it is ry of tau. So this is effectively your rz of tau. And now for the power spectral density and Fourier transform of a power spectral autocorrelation function and the power spectral density are Fourier transform pairs. For that reason, if I write it, rz of f is equivalent to, sorry, sz of f is equal to the power spectral density, the Fourier transform, sx of f plus xy of f plus syx of f plus sy of f. Okay, so if you look at this, these options, the first two are right. The first two are right. Now uncorrelated means any cross correlation will become equal to 0. Uncorrelated means the basic rule for uncorrelated is rxy of tau is equal to ryx of tau this becomes equal to 0. This is what the case for uncorrelated. So uncorrelated means these two terms both become 0. So similarly, these cross path spectral densities also become equal to 0. So effectively Rz of tau will become equal to, effectively, if it is the autocorrelation, yes, Rz of tau is equal to Rx of tau plus Ry of tau. If x of t and y of t are uncorrelated, it's the same thing here. S z of f will become equal to Sx of f plus Sy of f. So when these two are right results. Now, now okay, you've been asked this periodic signal m of t angle modulates a very high frequency carrier. Let the modulated signal be given by S of t is equal to AC cos 2 pi fct effectively plus kp in m of t, where m of t is shown in the figure, fi max minus fi min. Okay, so when you have, it's a standard PM signal, it looks like a standard PM signal. I will write it as a PM signal itself. S of t is given by AC cos 2 pi fct plus kp into m of t. We'll try to find out the instantaneous frequency, but this is a standard result. If it's good, if you remember it, if it is exactly in this format, fi is equal to fc plus kp by 2 pi into dm by dt, but we'll also try to derive it, not a problem. What is it? Fi is equal to 1 by 2 pi d theta by dt, which is equivalent to 1 by 2 pi differentiate it with respect to time, you'll get as 2 pi fc plus kp into dm by dt. If you write it down, it is fc plus kp by 2 pi into dm by dt. Now the question that is asked is fi max minus fi min. So once I write it as fi max minus fi min, it is all fi max. If I take it, it's the same thing, but only thing is dm by dt I'll have to make it maximum. Fc plus kp by 2 pi into dm by dt, which is maximum, minus the minimum value means fc plus kp by 2 pi into dm by dt, which is minimum. So if I subtract this, it is effectively kp by 2 pi into dm by dt, which is maximum, minus dm by dt, which is minimum. What is it's just that maximum slope minus minimum slope. The maximum slope is contributed by the positive slope, and the minimum slope is contributed by the negative slope. So if at all you have to look at it, in fact, this value here, this has to be a 5 here ideally. It's a 5 here ideally. It's just a small misprint. So if you look at 5, it is rising from 0 to 12.5. So this is said to be equal to 100k. So this is kp by 2 pi. What is this positive slope? It is rising 12.5 by 5, which is equivalent to, it is rising by 2.5. Look, if you look at it, it is 12.5 units. It's rising in 5 milliseconds of time. So 12.5 divided by 5, it is milli. So this works out to 2500, because 2.5k, which is 2500, isn't it? 2500 is a positive slope. That's a maximum positive slope. If you look at the negative slope, in fact, this is here. Here this has to be a 13, and here it is a 14. So if you look at it, it is falling by, if you look at it, it's falling by how many units? 17.5 units in 1 milliseconds. It is minus 17.5 in 1 milliseconds. So this is a minus 17,500. So these values are kp by 2 pi into the positive slope was 2000. Let me just verify. Yes, it was 2500 minus 2500 minus, this is minus 17,500, is equivalent to 100k. So this is more like kp by 2 pi into, this is 20k. I can write as 20k is equal to 100k. Yes, yes. So this will be equal to kp is equal to, this is 5 into 2 pi, which is equivalent to 10 into 3.14, more like 31.4. 31.4 will be kp. Okay. Now, if you look at the next question. Okay, that the it's a generator matrix is given, data is given, the encoder output is what is asked. So what is the code word? The code word is basically d into g. Now once you're doing this d into g, it's effectively 101 into this generation matrix. So an easy way of doing it is this. Effectively, if you want to do it at the easiest way, it is first value into this row, this particular row 1, 0 into this row 2, which is again 0, this 1 into this row 3. So effectively first into this row 1 plus 0 into row 2, 0, this 1 into row 3, and effectively addition means it's XOR operation. So if you do this XOR operation, 1 XOR 1, 1, 0 XOR 0, 0, 1 XOR 0, 0 XOR 1 is 1, 1 XOR 1 is 0, 1 XOR 0 is 1, 1 XOR 1 is again 0. So it's effectively 1 0 1 0 1 0. Answer is B. That should be the code, encoder output. Okay. So these are the solutions.
All right, students. So now let us discuss the questions of the general aptitude in this asked in this particular mock test. A certain stock exchange designates each stock with 1, 2, or 3 letter code, where each letter is selected from 26 letters of the alphabet. Okay, the certain stock exchange designates each stock with a 1 or a 2 or a 3 letter code. Any type of code is allowed, 1 letter or 2 letter or 3 letter. Okay, so where each letter is selected from the 26 letters of the English alphabet. If the letter may be repeated and if the same letters are used in different order, constitute a different code, means arrangements can be taken. How many different stocks is possible to uniquely designate with this code? It's a simple one only, because the codes can be a single a letter code or a 2-letter code or a 3-letter code, but all the letters are selected from one of the 26 letters, and repetition is allowed. Okay, letter may be repeated, repetition is allowed. So how many 1-letter codes? Let's write down both the cases, all the 3 cases separately. How many 1-letter codes? 26 possibility. You can select any letter from A to Z. How many 2-letter codes? Okay, for first position you have 26 option, for second again 26 option, because repetition is allowed, to 26 into 26. If repetition was not allowed, then 26 into 25, or then you can write 26p2 also. You can directly use NPR formula if repetition is not allowed. Then how many 3-letter codes are possible? The first letter can be 26, has 26 possibility. Second letter also has 26 possibility because repetition is allowed. Third also has 26 possibility. Okay, so net answer is like 26 plus 26 square plus 26 cube. That is the only logic to solve this question, and hence a 1-mark question. What is going to be the answer here? Let me write down the answer. Let me compute and write down the answer here. 18,278. 18,278, answer is A. 18,278, the answer is going to be A. Okay, next one. The following image has been seen in a mirror, then seen in resultant, then seen the resultant image in water. Okay, how it looks like. Okay, the following image has been seen in a mirror. Okay, now when we talk about mirror, normally the mirror, okay, there are 2 images, mirror image and water image. Mirror image is normally considered as the image about vertical, and water image is the image of an object seen, okay, about horizontal. If I talk technically, this is y-axis and this is x-axis. Okay, so this image, this is the image seen in a mirror. Okay, what will be the original one? Okay, what will be the original one? Now see, I'll only follow, where the question has gone, sorry. Yeah, I'll just only follow the edges. Okay, if this is the mirror, how the original one will look like? How the original one will look like? I'll not be able to draw this entire good picture. But if I just reflect it about vertical, image of image will be original picture, na? Okay, so if I just trace the boundary, it should be something of this kind. Okay, right, na? This point. Just tracing the outline of this bird, it looks like this. Okay, now if you take, okay, suppose this is mirror. Now, if you wanted to take its image on a water body, okay, which is about horizontal, how the image will look like? Okay, horizontal means upside down. The image should be upside down. Okay, not left to right. About vertical means left to right or right to left. Now upside down. So this point, okay, has to be seen something like this. So which image will match like this? I think answer is C. Okay, yeah, correct answer is C. Correct answer is C. Okay. So correct answer for this question based on simple images, spatial aptitude. Okay, answer is C. A two-digit number is such that the sum of the squares of its digit is 85. Okay, so a two-digit number, how you can normally take a two-digit number? Suppose the number is xy, the digits are x and y. Okay, such that the sum of the squares of its digits, that means x square plus y square is 85. If the digits are interchanged, then the new number is more than the original by one digit, largest perfect square. Just keyword, just basic twist of words it is. Okay, the new number is more than original number. Okay, by how much? Now, what is the new number? Okay, when the digits are interchanged, the number will look like yx. Okay, so the new number, how do you write down the value of the number? If it is xy, the number is 10x plus y. This is units place. This is the tens place. Okay, now this is units place and tens place. The value of the number will be 10y plus x, and this new number, that is 10y plus x, is more than the original number. What is the original number? 10x plus y is more than the original number by how much? By one digit, largest perfect square, 9. The perfect squares are 1, 4, 9, then 16. The one digit largest square is 9. Okay, so when you simplify 10y minus y, 9y, x minus 10x minus 9x equal to 9. That means you have one more relation, y minus x equal to 9, and x square plus y square is 85. You can get x and y. Okay, right. Or directly if I square here, okay, if I square here, y square plus x square minus 2xy is equal to, sorry, this was not 9. This will also be cancelled as 1. This is 1. Okay, x square plus y square is 85. 85 minus 2xy is 1. Okay, so 84 by 2. What is the value of xy? 84 by 2 becomes 42. 42. So what can be the digits? Okay, whose product is 42 and the digits differ by 1? Okay, 6 and 7. Simple, 6 and 7. Okay, so xy is 42. The difference y minus x, so y should be greater. So the number can be 6 into 7. 6 into 7 forms 42. 6 into 7 forms 42. Okay, so what is the original number? Okay, what is the original number? Right here. What is that original number? 67. Okay, what is twice of that number? Because final question is sum of the digits of twice that number. Okay, twice the number, 134. Okay, sum of the digits, 1 plus 3 plus 4, 8. Answer is C. Okay. Sum of the digits, 1 plus 3 plus 4. So answer is 8. Okay. Yeah. Just question is very basic, just understanding of the language. Okay, just have to focus there. Number 4. Only one term of the following series does not follow the pattern that others follow and hence become odd one out in the group. Find the odd one out. Okay, find the odd one out. So, you know which one of them does not follow a pattern that others will follow. So, let us see. Now, whenever it is letters, now you can count their position or you can write down a sequence like, okay, like the first one is A, D, H, M, na? Okay, A, D, H, M. Okay, see like this. It is A, B, C, then D, then what is there? E, F, G, then H comes, then I, J, K, L, then M comes. Though, what is the pattern in the first one? This is the number A, D, H, M. This is the pattern given. Okay, that means between the first two letters were omitted, then 3 letters were omitted and the next digit came, and then 4 letters were omitted and then the next letter has come. Okay, now let us see the next one. What is the next one? ORVA here. Okay, ORVA. Okay, O, P, Q, R, S, T, U, V, W, X, Y, Z, and then after Z you can restart A. Now you see the pattern again. Okay, O, R, V, A. You see, 2 letters omitted, then 3 letters omitted, 4 letters. Same pattern. So A and B, these two are not A and B. The first two are same pattern. You have to find one which will not follow the pattern. Then FIMR. Okay, FIMR. So I'll write the pattern now. F, G, H, I, J, K, L, M, N, O, P, Q, R. Okay, now let me highlight the given word. Okay, what was given? F, I, M, R. Same pattern, 2 omitted, then 3 omitted, and then 4 omitted. Correct. Okay, so obviously the odd one out has to be this one, but I'll tell you why. It has to be this one. Let's write down the pattern again. M, N, O, P, Q, R, S, T, U, V, W, X, Y, up to Y, na? Correct. Now you see M, okay, then Q, M, Q, U, Y. See, 3 letters here, 3 letters here. Okay, 3 letters between, every 2 letters. So this is what is a separate odd pattern, which is not followed by others. So correct answer is M, Q, U, Y, option number A. Okay, right. A basic, series or odd one out question from alphabets. Next one. Normally there have been even 2 mark level question from this category. Okay. Okay, 5th and 6th, 2 verbal question. What is there? I'll just tell you the answer. Which of the following is closest in meaning? That is synonym to the word circuitous, and that is option number B. It means indirect. Okay, and then 6th, okay, we will not discuss verbal here. I'll just tell you the answer. There is a passage given and you have to find the conclusion of it. What is there? After several defeats in wars, Robert Bruce went in exile and wanted to commit suicide. Just before committing suicide, he came across a spider attempting tirelessly to have its net. Time and again, the spider failed but did not deter it to refrain from making attempts. Such attempts by the spider made Bruce curious. Okay, thus Bruce started observing the near impossible goal of the spider to have the net. Ultimately, spider succeeded in having its net despite the several failures. Okay, such act of the spider encouraged Bruce not to commit suicide. Bruce also motivated. Bruce went back and won many a battle, and the rest is history. Okay, which of the following assertion is the best supported by the above information? Okay, which of the assertion is best supported? What is the best conclusion from the passage that you can take? Failure is the pillar of success. Honesty is the best policy. Okay, first of all, there is no discussion about honesty here. Of course, hard work is the important message here. Life begins and ends with adventures. Okay, so now it's not adventure. It was something, worth do or die situation. No adversity justifies giving up hope. Okay, that is what. Okay, that is what Bruce learned from the spider, that whatever worst situation it is, okay, if you give up, nothing is going to happen, Okay, but if you keep trying, because any phase of life, even GATE exam, okay, if you give up, last 1 month is there, many students give up. But there is only one guarantee I also give you. If you give up, nothing is going to happen, guaranteed. But if you keep trying, although there is no guarantee, but if you keep trying, there is a high probability and high possibility you come up with the results you wanted. Okay, correct answer for this passage is D. Okay, correct answer is D. Okay, yeah. The best possibility, okay, the best possibility, because it is also not only about failure or success, it is also about Bruce was wanting to commit suicide. He was thinking into that to a worse situation. Okay, otherwise, failure is pillar of success is also one of the sub messages of this one that you can say. Okay, B and C are totally out of league here. Okay, anyways, chalo, we discussed that also. 7th one, the average ages of the MPs of lower house and the upper house of a parliament are 50 and 70 years. Okay, respectively, lower and upper. One MP shifted from lower to upper house, thereby the average ages of both the house were reduced by 1. Average ages of both were reduced by 1. Find the age of that MP. Suppose the age of that MP is suppose X if the number of MPs in the lower and upper houses are in the ratio 3:1. So let us say the MP in the lower house are 3k and that in the upper house are k. Because the ratio is 3:1, we can take the number as 3k and k respectively. Okay, so what is there here? Originally situation, if I talk about the original situation, let me write it here. If I talk about the original situation, okay, and let us write down a simple formula. Sum is equal to average into number of observation, because average is sum upon number of observation. What is the sum of the ages of the members of the lower house? Is the average, which is 50, and the number of people is 3k. 50 into 3k, you can call it as 150k. Okay, what is the sum of the ages of the upper house people? The average is 70 and the number of people is k. So this is 70k. Okay, this is 70k. Okay, number one thing. Now 1 MP shifted. Okay, so after shifting, what is happening? After shifting again, the sum, okay, which was originally 150k will be now reduced by x. Okay, because one member went from lower to upper. Okay, and the age of that MP, suppose x, that is what we need to find. And the average is again average. Now average reduced by 1, 49. Okay, and the number of people originally were 3k will now reduce by 1, 3k minus 1. Okay, what happens to the upper house? What happens to the upper house? Upper house 70k was the original sum plus x. That MP came, so overall sum of the ages is 70k plus x. Okay, is now average into sum of observation. Average here also becomes 69. Both averages reduced by 1. But original people here were k. Now it will be incremented by 1. That is k plus 1. Okay, so if I add these two now, if I just add these two here, what do I get? 70 plus 50, 220k. X will be cancelled. At least k I will obtain. Okay, then 49 into 3, 147 plus 69. How much? 69 and 147, na? 620, 216k. Okay, minus 49 plus 69. Okay, so plus 20. Okay, easy. 4k equal to 20. So you got k equal to 5. Okay, and if k equal to 5, okay, get the value of x from here only. 70 into 5, 350. Or sorry, just we'll subtract here. Okay, let me rewrite this. 70k plus x equal to, open the bracket, 69k plus 69. Okay, so this becomes how much? X equal to minus k plus 69, and that becomes 64 because k is 5. 64. The answer is 64. Option number C. 2 marks question around the average, basic average and the language concept. Average is also simple. Average, you all know, average is sum upon n, or sum of the observation is average into n. Main is putting down the given equation into the given statement into equation. Okay, next, number 8. Okay, a clock question. The minute hand of a clock meets the hour end at an interval of 67 minutes. How much time does this gain or lose? Now the clock gaining or losing means clock is either running fast or running slow. What is the situation here? Minute hand of a clock meets the hour and at an interval of 67 minutes. What? So let us assume there is some gain or lose. That means this is not the actual interval where the minute hand and the hour hand should meet. So what is the actual interval where they meet? Okay. The first meeting, okay, let's talk about the hour hand and minute hand as HH and MH. Okay, what is the first meeting? The first meeting is exactly, okay, 12 a.m. or 12 p.m. whatever, we just talk about the 12-hour format in these clocks. Okay, it is 12:00. Okay, that means the next interval if I have to find, the next meeting if I have to find, the next meeting is at 1 hour and some minutes. Okay, then 2 hours some minutes. In every hour they will meet, na? Okay, normally people think 1 hour 5 minutes. No, it's not 1 hour 5 minutes. Okay, because if this is 12, this is 1, you might think, okay, this is the first meeting. Okay, but next meeting, when you think 1 hour 5 minutes, now you think that minute hand is at 5 or is at 1. Okay, hour hand will be slightly away. Hour hand will not exactly be at 1. Na? It will be at 1 only when the time is 1 o'clock. 1 hour some minutes ahead, hour hand will move forward. Okay, only the minute hand will come at this reading. Okay, so they will not coincide. It is 1 hour 5 minutes something. It's not exactly 1:5. Okay, how much it is? So there is the formula that you should always remember in case of clocks is the angle between the hands of the clock the angle between the hands of the clock is given by modulus of 30h minus 11 by 2m. Now, I'll tell you, sometimes in GATE there have been questions only on this formula. Okay, time is given as, any time is given. Suppose the time is 8:52. What is the, angle between the hands of the clock? Okay, you can find by logic also. Okay, that logically also it is easy, but this is a direct formula because it's a repeated concept, you can say. So you can use this 30h minus 11 by 2m modulus. Okay, so when the h is 1, okay, when the h is 1 and coincide means how much angle? Okay, the theta is 0. Theta equal to 0 because we are talking when do they coincide. When do they coincide? Okay, so 0 equal to, putting h equal to 1, okay, 30 into 1 minus 11 by 2m. Okay, this has to be 0. Okay, this has to be 0. Solving this, you get m is equal to 60 by 11. Okay, 60 by 11. So this time, okay, is actually 0, 1 is to 60 by 11 minutes. 60 by 11. So what is the gap between them? Okay, this are now 12 is actually 0, 0. Okay, it's 0, 0. 12 is also 0, 0 because I told you it's a 12-hour format clock. 12 means reset, repetition. You can also call it as 0, 0. So what is the difference between them? What is the difference between them? Okay, the time for the next coincidence is 1 hour and 60 by 11 minutes, or 1 hour is 60 minutes. So 60 plus 60 by 11 minutes, which turns out to be 720 by 11 minutes. Okay, I don't need its exact value, but I'll tell you if I have to write down its exact value, just to explain you the concept. Okay, how much it is? 720 by 11, that is 65.45. 65.45. Now, what is the given interval? 67 minutes. Okay, and this is greater than 720 by 11. 720 by 11 is how much? I told you it is 60. Sorry. Yeah. So that is 65.45. So given time is 7. Just a second. What is happening? Yeah. So given time, the actual time should be 65.45. Okay. The original time given is 67, which is greater than that value. That means the clock is running slow. It is taking more time. Okay. That means it is losing time. Clock running slow means it is losing time. The answer has to be losing. But losing how much? Okay. Losing how much? Okay. When the clock shows 67 minutes, what is the difference first of all? Okay. Let's write down the difference. Okay. 67 minus 720 by 11. Okay. Will become how much? Okay. Let me write down the calculated value. It's this one minus 720. Okay. It is 17 by 11. Okay. So that means the clock has lost how much time? The clock has lost, okay, this much of the time is lost. It is late by this much time. 17 by 11 minutes lost in 67 minutes. In 67 minutes, okay. So let me write it this way. Okay, 67 minutes, how much does it lose? 17 by 11 minutes, okay, lost. So in 1 day, or first let's convert to the unitary method. In 1 minute, how much does it lose? Okay, divide by 67 here. This much minutes is lost. Okay, so in 1 day, okay, how much minute it will lose? Okay, the 1 day has 24 hours. See, this is per minute, na? Now 1 day has 24 hours and every hour has further 60 minutes. So these are the total minutes within the day. Okay, these many minutes will be lost. Okay, and this is approximately how much? Let me do the calculation part again. How much it is? 17 into 24 into 60 to be further divided by 11 and 67. This is 33 point something. Okay, this is 33.2157 minutes lost. Okay, so answer has to be lost 33 and the whatever fractional part. No need to worry about this. Answer is 33 point something. Answer you can mark as C. It loses time and 33 point something. Okay, this value should be probably coming out as what I have written there. Okay, this fractional value. This is what is the concept of this question. A good question from clocks, I would say. Okay, MCQ 2 marks. Next question, number 9th. Arrangement, a very expected question, arrangement. Okay, just have a look into it, read this and get the answer. Easy one only, because it's a linear arrangement, it's not even circular. Okay, because many times you can get the question on circular arrangement as well. Okay, dear. 8 people, namely A, B, C, D, E, F, G, H, stand in a row and face north, but not necessarily in the same order. A stands at the end of the row, B stands third to the left of C, who stands second to the left of A, F stands, so see, let's go one by one. There are 8 people, A, B, C, D, E, F, G, H, they stand in a row and face north. Okay, I'll complete the question here only. Suppose this is north and 1, 2, 3, 4, 5, 6, 7, 8. Okay, A stands at the end of the row. Okay, A stands at the end of the row, but which row, which end, that is not clear right now. B stands third to the left of C, who stands second to the left of A. Now, okay, listen, B is third to the left of C, who stands second to the left of A. Now A is at the row. Can A be here? If A is here, left of A will not be possible. Na? See, left of A will not be possible. That is, A is at the right side. Okay, right side with reference to our hand. Okay, and then C is second to the left of A. First left, second left, C. Okay, and then B third to the left of C. Okay, first left, second left, third left. This is B. So B also fitted. F stands third to the right of E. F and E both absent here, forget. H is immediate left of G. Both are not here. H is immediate left of G, who is not adjacent to C. Okay, G, who is not adjacent to C. And H is immediate left of G. Now, if H is immediate left of G, that means H and G are together. Okay, and together means only 2 possibilities are available. Okay, that too H left of G. So, H left of G means one possibility here HG, but they clearly say G is not adjacent to C. So this case is ruled out. Okay, you get here H and G. You get here H and G. Okay, now F is third to the right of E. F is third to the right of E. Okay, so E has to be here, so that 1, 2, 3, third right, F will come up here. Which guy is left? A, B, C, D is left, will come up here. E, F, G, H, everything is there. Okay, now they can ask any question. We have to complete the arrangement. What is the question? How many people are standing to the right of E? Okay, 1, 2, 3, 4. Option is D. Okay, these are the 4 people who are standing to the right of E. Okay, answer is D, 4 people. A decent question on arrangement. Next one, here it is. The last question from aptitude. The previous one was 9th, I guess. Yeah. Here it is. In a triangle PQR, PQ is 60, QR is 11 and PR is 61. Mind it, first let me tell you, this is a common Pythagoras triplet only. 60 square plus 11 square, you can tally from the calculator as well, is 61 square. Okay, that means it's a Pythagoras triplet and hence a right angle triangle. Okay, so given triangle has to be a right angle triangle. Find the radius of the inscribed circle. Now see, for you, I'll tell you one reason of putting this question is you don't have to remember specific formulas in terms of, inscribed circle or, the triangle inside the circle. There are several cases, na? Orthocenter, incenter, circumcenter. Okay, you don't have to remember specifically them because one question comes up and that will basic geometry if you know, basic theorems if you know, you should be able to solve. That is what I say. Okay, so let us just solve this question normally and manually, easy only. Okay, why? Because if I just take a right angle triangle, okay, just have a look into this one. And then take a circle which is inscribed inside this. Okay, approximately this will work. Okay, so have a look into it. Okay, this is the circle inscribed. This one is PQ is 60 and QR is 11. Okay, so this one will be P, this one will be Q, this one will be R. Okay, and then suppose this is the center of the circle. This will become the radius, and also all the 3 sides are tangent to the circle. This is the center of the circle, suppose O. Okay, then here, and all these are radius. Now, always remember, okay, the line from center to the circumference is always known as a radial line, and radial line to a tangent is always perpendicular to the tangent at the point of contact. Okay, that is why this angle as well as this angle as well as this angle, all of them will be 90 degree. The radial line will be perpendicular to the tangent, Now, from a common external point, if two tangents are drawn to a circle, they will be equal in length. That means if this is x, this will be x. From here, if this is y, this will be y. From here to here. Okay, and from here, if this is z, this also will be z. This much portion, okay? Right. I repeat the statement. From a common external points, if two different tangents are drawn to the same circle, they will be equal in length. Okay, they will be equal in length. Okay. Now, simple logic of solving this question is area of triangle PQR. Okay, area of triangle PQR. Now, I will explain how this area is. See, because this is right angle, just take this line here. Okay, what is the area of this much part? Okay, right angle triangle, because of perpendicular. Okay, half into base into height. Base is x, height is how much? Radius. This is the radius I want. This also will be r, this also will be r. Okay, so how much will be this much of the area? How much will be this much of the area? Half into base into height. Similarly here, base is same, okay, height is same. Okay, now similarly, if you form the triangle here, okay, base will be z, height will be r. This triangle, base z, height r. Okay, and then similarly, one last case, you can find this, you can form this. Okay, so area of the triangle PQR. Okay, what is the overall area? Half into base into height. Overall base I know, no, that is QR, 11. And overall height, this part is 60. This part is 60, is equal to sum of all these areas. Okay, what is this? Half into x into r, this will come 2 times. Okay, twice of half into x into r. Plus similarly twice of, how much is this area? Base z and height r. Okay, so half into z into r, similarly 2 times. Half into z r. Okay, plus 2 times half of, what is this? Next one will be yr. Okay, and half you cancel. Okay, or rather don't cancel 2, just cancel this half. The left side 11 into 60, and right side take 2 common. Half is cancelled from the left side. Okay, and if you take 2 common, or rather don't take 2 common, yes, r common, then you will be left with 2x plus 2y and plus 2z. Now, what is 2x plus 2y plus 2z? X plus z plus y is becoming the total perimeter. Okay, is becoming the total perimeter of the given triangle. That also we can calculate. Okay, so 11 into 60 is equal to r times, okay, the total perimeter, which is 60 plus 11 plus 61. What should be the value of r? 11 into 60 is divided by, this is how much? 120, 130, 132. Okay, so this will cancel as how much? 110, this is 12 times. 60 by 12, answer is 5. Answer is 5. That is option number B. Option number B. This is the concept of solving the question. All right. Okay. Any doubts you can mention in the comment box, or you can discuss in the Telegram. You can let me know any doubts in the Telegram. Okay, these are all the solutions from General Aptitude. And at the end, let me again give you a reminder that, guys, the first offline course at our Hyderabad Center for GATE 27 for both EC and EE has been announced, and it starts 26th of February. It starts 26th February 2026. All right, guys. And if you are planning for offline coaching for AE exams like Telangana or AP, Genco, Transco, Discoms, the next offline batch at our Hyderabad Center starts 21st of January. Okay. Also, there are online live courses for GATE 27 and GATE 28 in case you can't travel to Hyderabad but still want the same content by the same expert faculty team. Okay, you can also enroll to our online live courses, where the first online live course starts 2nd February. Okay, right. So if you're college going student, this will be more ideal for you. But if you have completed college, I would advise to walk down and travel to Hyderabad and study in a highly competitive atmosphere in front of the faculty, pure guidance, and perfect for discipline as well. You study entire entirely in front of the faculties and with the proper dedication. Okay, but yes, if you're college going student or anyhow you cannot manage to come to Hyderabad, you can also enroll to the online live course to be taken by the same faculty team. It is available for both GATE 27. GATE 27 1-year validity fees 99.99. For GATE 2028 with 2-year validity, the fees is 28,999. Alright guys, the platform will be Om Live app, and there's a 10th additional 20% discount and a 2 months extra validity benefit if registration is done till 10th of January. Okay, you just have to use the code OMGATE20. Alright guys, so yeah, that's it from my side, and I hope you have enjoyed this entire video. All the subjects by the entire team of Om Institute, okay, have been discussed. Okay, the solutions, the detailed solutions of the mock test. Hope you have performed decent in the mock test. Or again, if I repeat, if you have not performed satisfactory also, don't worry, it's still good, because you have come to know about your performance 1 month, or rather 34-35 days before the actual GATE examination, so that the next 1 month you can plan your preparation accordingly, rather than just doing the repeated things. Okay, going in the same direction where you are still doing the same mistake. Rather, you improve, you learn how much you scored here and why you could not score what you wanted. What went wrong? If you know it, then only your actual GATE exam will be beneficial. So no worries if whatever the today's exam was, if it is good, you will definitely add on to some confidence. Otherwise, take it as a positive thing if you don't score good also, because you can work, and the same mistakes, same error should not happen in the actual GATE examination, which is on 14th or 15th February for W or EC respectively. Okay, so all the very, very best for your final examination. Keep preparing and keep subscribed to the Om Institute YouTube channel, because this 1 month, okay, you're going to get a lot of videos, and very soon marathon sessions are also going to come up. We are going to announce them soon. Okay, so stay tuned, stay subscribed, because the mayhem, the grand marathon sessions, okay, for the entire revision of the subjects are going to start on this Om Institute YouTube channel. Okay, this is Rakesh Talreja signing off. Bye bye. Thank you. Stay safe and take care of yourself.